Okay, I think I figured it out. I think it's one button when it's not a scheduled stream, but then for some reason, when it's a scheduled stream, it's an extra button. I figured that out quick, but I don't know. Okay, anyway, sorry I'm late. Um, don't think anybody was just waiting. Hopefully not. I should get a fun waiting screen. Anyway, sorry. I will get better at being more on time. I had a thing today at 8. Why did I have a thing at 8? I don't know, but I did. So, and now I'm here. But yeah, my bad. I will try to be like right on time in the future so people can expect like go live at 9 means go live at 9. Yeah, yeah. Sorry, Hassan. Sorry, sorry, sorry. Um, I do not want to make a habit of it. Yeah, I had a thing at 8. I thought I would be on time. Getting the room set up takes a while. We have a company in the room too, so sometimes I have to shuffle things around a little bit, and that takes me an extra minute, and I just don't plan for it good. Anyway, still my fault. So sorry, sorry. While we wait for people to trickle in, I'm going to do a quick chore. I will actually put it on screen though, so you can just watch the chore. Kinda. Some of it'll be on screen, some of it won't be on screen. Here, hang on. Let me share the screen as soon as I make sure everything is good to go. Uh, there we go. Okay, yeah, you guys can see it. That's fine. Um, all right, I'm just digging for numbers for somebody. It's anyone in the chat doing ICML rebuttals right now as an author or as a reviewer? And wait, is the supplementary not in the integrated PDF? Because that would be annoying. I guess it's not, right? Um, okay, that's fun. All 2 versions. Trying to remember what's in my own paper. Uh, there we go. Find the supplementary. Anyway, how's everybody doing? How's it going, Lone? How's it going? Or Loan? Lone? Loan? Mikan? I don't know. How's it going, Hassan? Good morning if you're in US time zone, or I guess if you're East Coast, actually, it's already good afternoon. Good evening if you are Europe. Good late evening if you're in the Middle East. Um, Good night, I guess, if you're joining us from China or India. Where's everyone from? If you feel comfortable, feel free to throw it in the chat real quick. I mean, I think I know for some of you, but like just to kind of share with each other. Did I not put these numbers here? Really? Oh, that's so annoying. Why did I not do that? That's dumb of me. Did I really not? Okay, that's a problem for me later. Okay. ICML is too big for me at the moment. What about ICML workshops? I guess those wouldn't have the same review rebuttal deadline, but I don't know. Is it too big? Like, what I mean is, um, it's more about the idea that you have and the experiments you run and the paper you write than it is about your like years of experience, right? There's undergrads that write papers at the top conference, but I guess a lot of it comes down to like the resources you have access to, the mentorship you have access to. Um, why did I search computer vision Hugging Face? That's not what I want. Hugging Face, daily papers. I'm sorry. I need to, we'll actually do it right now. I need to set up my bookmarks in the new, okay. Do I have like a, okay, so we're going to do something. We're going to bookmark this on the bookmarks bar, but we are going to go here. We're going to edit it and we're going to change the URL because it'll default to the today's date, right? So like now when I click this, yeah, it just defaults and then I can click weekly and then bam, I'm good to go. Because my old one was like specifically that week that I bookmarked it and that was always annoying. What about arXiv computer vision? Let's grab that. This is fine. Let's we will double check it. arXiv CV. Let's grab arXiv computational. Oh, it's just computational language. Man, how many different names does NLP have, right? Natural language processing, computational language, computational linguistics, and there's probably some that I'm forgetting about too. Let's bookmark that. Let's call it arXiv NLP. And then let's grab arXiv machine learning. Although I feel like Does it almost feel like the quality of this feed is often just really like, I don't know. I haven't really liked the stuff that we see when we choose to look here. But anyway, we got that guy. Got these cool. Oh, Pakistan? Oh, wow. How late in Pakistan right now? Okay, cool. Yeah, please don't process my personal information website. That's basically a clock. That's crazy. Um, okay, somewhere between these, right? But I kind of want to know. Oh man, capital of Pakistan, capital of Pakistan. Oh, this shouldn't take me so long. I keep thinking of random cities in Afghanistan though, which is not obviously not right. Oh, Islamabad, right? Am I crazy? Is this just my bad geography? Um, Here, hold on. Let's test my geography in real time. Uh, Sorry, my like screen is lagging. Um, there we go. Capital of Pakistan. Yeah, Islamabad. And then current time. Sorry, I didn't see Islamabad on that big list on my site. Oh, okay, so it's late, but not like insanely late. Oh, Karachi? Wait, does Pakistan have multiple time zones? Oh no, it's same time zone, right? How far off is Pakistan from India time? Is it like 1.5? Oh, it's just half an hour. Okay, good to know. Hi, can I get an answer of one question honestly? Yeah, I'll answer whatever questions. We're just getting the stream sort of set up. We need to open up some papers. From Brazil, it's lunchtime now. Well, Brazil's an hour forward from US East Coast, right? Like, so it's like one something? Or is it like, or because of daylight saving time, are they lined up for a minute? Okay, so let's open, we always open the top, no matter what it is. This time it's drones. That's, okay, interesting. Okay, and now we get to be a little more picky, right? Deep reasoning, sure. Another Chanwen paper. I wonder if this paper was kind of done before a lot of those people left, but it also says that it's the Chanwen pilot team, so uh, maybe that's just not the people that left at all, right? Maybe that's a team that's totally intact after the recent changes at Alibaba. Okay, DataFlex. Framework for data-centric dynamic training. Let's see what that means. Multi-shot video generation for interactive storytelling. We like to open the video gen papers. Oh, a friend was sharing this in a chat that I'm in. And then this should be some long video thing, right? I don't know. Let's see what that is. Or maybe just long sequence in general. The latent space. I don't know. That kind of grabs my attention, right? I guess that's the point. Generative world renderer catches my attention. This is going to be some agent thing with some medical stuff, right? Do I care? Task-aware proposals, speculative sampling. All right. Anyone seeing anything that jumps off the page at them? Hello, Invika. Is that how you want me to say it? By the way, coding by Sammy. I'm happy to answer the question whenever I see it. Just so you know, I didn't forget. It's just I don't see the question yet. I don't think we looked at VGG RPO yet. Ooh. I have a friend that had a paper, and I had missed it. And it's a paper that's like very related to the stuff that I like to do. It's this one. So I wanted to grab this guy. There we go. Okay, we'll do that at some point. Maybe even a little earlier in the day. Because it's the kind of paper I normally like to do. First off, I like to cover friends' papers when they come out. And second, it's actually like very related to the paper I just did in a lot of ways. Okay, world grounded. Ooh, I like this. And it's a Hunyuan team, so curious what they're up to. One thing that I'm really exposed to now, by the way, that I hardly did any of before is like pre-training large models, you start to obsess over the training dynamics, not just in terms of your monitors, like the loss or like the metrics you've wired into it, but also like lately I'm getting really into like grad norms and param norms and like especially when you have these hybrid setups. Like, I don't know how many of you know this, but if you don't, you should. Um, is this the right post? Does this actually give the explanation, or is that buried somewhere else? Where do they give the settings? Yeah. Okay. So yeah, this is a fun setup that kind of explains basically how to split up your params between mu1 and atom w. Um, and hypothetically, you just tune learning rate and weight decay, right? But then you like, it's very interesting to see how differently the norms of the different params evolve. And the funny thing is, because of the nature of the params you assign to mu1 versus atom w, it's not even like you can just look at the mu1 ones being bigger and be like, oh, something different is happening here, because they're different types of params, right? But so I've gotten into like looking at like the Honyon model and being like, ooh, what are the param norms of the model that they release versus like what are the param norms of the model that I'm currently training, and like comparing the sizes. And also like there's a weird effect in some models, at least on some schedules, where the param norm gets higher and higher and higher and higher until it reaches some point and then it like flips. Um, and so I don't know. It makes me wonder, like a lot of the models that I see released, like where on that spectrum are they? Like, did they train long enough to where it flips and they start going down again, or do they just release like kind of early? Because you can get good results even earlier in that pipeline, right? And depending on your resources, you don't necessarily have time to keep going. And one question that I have is, are my metrics even going to keep getting better even as the norm starts to kind of flip back around? Ooh, quick question for the chat. If you're not too familiar with param norms, uh, first I'll tell you how you compute them often, and then you can think about why it makes sense for them to just kind of get bigger and bigger until they're really, really large. The formula is pretty easy though. Um, Formula is just like, let's say that I'm getting my param, right? So for param in group, let's just pretend that's the code. My running norm can be like, you have to make sure it's a float, obviously, right? So just squared, and then, so it's like a running norm. Okay. You keep a running norm, and then it's just square root of norm, right? That's what you consider like the param norm for your model. You would add up all the norms across all the params, take the square root. Just so you know what I'm even talking about. Okay. Hey, okay, sorry. Let me catch up on questions. Have you used arXiv? No, should I use it today? I've been looking for like a decent companion app. But the thing is, like, I don't, maybe we should go because the like top paper will be something different. Ooh, I saw this one this week too. Maybe it's nice to get more votes. What else am I going to get out of arXiv? Because it's not like I'm trying to have a very principled search of arXiv, right? That's kind of what the Hugging Face is like, oh, let's look at the top voted stuff. On this, it's more like, let's just try to skim for titles that jump out at us. I don't know. Pitch arXiv to me, and maybe we'll use it. So is it really worth it to learn math like CS229? You should definitely know CS229. Like if you want to do anything ML at any level, I think even the most black boxy person working on ML, like even the guy that's going to do like integrations for someone's agentic thing should still know CS229. It's like how in CS we should all take a systems course, and like, do you need to know how to write assembly? Not necessarily, but like it's nice to find the bomb in the assembly code that one time to just like roughly have an idea of what's going on under the hood. I think it's a decent abstraction to have. So yeah, especially yeah, if the goal is to get into deep tech startups, uh, definitely worth it to actually like know. And I would say even go beyond CS229. Gen Searcher looks cool too. Wait, sorry, was Gen Searcher on the screen, or do you just want me to look it up? I'll look it up regardless, just because I'm not gonna. This one, right? I got it. Agentic Searcher or Agentic Search. Oh, by the way, um, is this paper going to be about wine? Because we found one of these papers the other day, and it was actually about wine. But I think they're just using the name. But we're still going to open it, and we can see. Because I think that's pretty funny. We actually read a wine paper a couple weeks ago. Dynamic MOE with drift order. No. I continue learning, but I don't really feel like it right now. Video generation models as world models. Okay, this kind of feels like a position paper, just reading their little highlight, but we can see what it actually is. Any more papers from the chat? You can import private. You're saying how to import papers? I kind of like reading the raw paper. Are you saying when I click into the paper, it's going to be like, I would ask it stuff in real time? Like, I don't know. That's not. Maybe I'll play with this off stream and I'll discover it's actually something I really like. But for now, it's like, I kind of just want to read it myself. I don't know. Okay, let's see. Cut claw. Okay, I think I saw cut claw here somewhere, right? But I'll just grab it from elsewhere. Cut claw. That's fine. This guy, right? So we got cut claw here, and you had me open Gen Searcher. We'll pull this over. You're having me read some it was on Hugging Face? Yeah, I believe you. I'm not gonna scroll around and potentially not find it. So I got him though, I think. I got him here and here. So we'll go over them in a second. Pushing me out of my comfort zone a little on the agentic stuff, but it's fine. I'll read enough of them and that'll be cool. This is interesting. This is one of the lower upvoted ones here. But on arXiv, it was actually, for some time period, it was the most popular one. I don't know if this is weekly or daily. It just says hot, so probably some sliding window. Oh, wow. But if I go for likes, oh, PE Core. This is all time. PE Core is the most popular on the site of all time. That's interesting. It's a good model. It's a really good model. Okay. The Void Paper 2, that was also trending this week. Did I not grab that? And is that here? Okay, there we go. Oh, I did see that. I didn't open that for a reason. We can talk about it, though. It's fine. This is going to talk about. Yeah, that I saw that within my little network. I think that one went viral on LinkedIn or something. It's really funny to me. There's this crazy trend, and I keep meaning to talk about it on the stream. Oh, sorry. It redacts external links, Shanmuka, so you'll have to like send me the title. It's even hard for me. I can try to remember the number. 2604-02296. Here. It won't even let me. Oh, we got Void. Yeah, we got Void. It's up here. Did I put it? Yeah, I put it right here. Okay. Here, let's go into these first 4. If there's any other chat papers, put them in. I'll do them first. No guarantee I get to the other ones, by the way. We're doing it slightly more casual. I will do all the papers with the timer to start. But like when the timer ends, I might just stay there if I think we're pretty close to having what I want. And here, let me adjust all the papers for the vertical feed real quick. I need to go and I need to measure. Oh, geez. I need to disable the table of contents thing. That's really annoying. That's probably something in my Chrome profile if I went to look. This is a little too big. There we go, right? Even still, actually, I guess this is a 90 on this profile at least. Yeah, I guess so. What about this one? Maybe 95 works for this. Nope. Maybe 93? Yeah. No. 92. Okay, I guess 92 for Void. What is this format? Off the top of my head, I'm not sure. Let's see. This one looks like an 85er. Yeah. There we go. Okay, we got these 4. Any other papers in chat? I'm checking. Any interest in diffusion / flow matching? Yeah, that's we could say in Vika that diffusion and flow matching is like my main thing at the moment. Feel free though to put up like I'll go over any paper, even the stuff I'm not interested in. Like, am I interested in agents? Not really. But I'll go over it. Like, I'm happy to read anything. What's your advice for startup? Should I go into deep tech startup so I can have a moat, or is it like build the wrapper startup, but they are flooded and can be replaced? It depends. I mean, those are obviously 2 completely different things that require 2 completely different types of expertise. I would say if you're like earlier in your education, like you were asking me about CS229, like if you are like an undergrad freshman, like definitely just try to build, deep expertise, I would say. And then, you can do whatever you want with that later. But it's not as simple as like, oh, I'll do the deep tech startup, right? You have to have some deep expertise and some ideas that are really different from what's currently out there. Whereas I think building wrappers is a lot more about identifying clear and obvious business need, right? there's a lot of overlap. You need to market yourself, you need to market your company regardless. It's also different if you're talking about being a founder, which I have no advice for because I'm not a startup founder or an entrepreneur, versus just talking about trying to work at one. Um, yeah, it really depends. Even wrapper companies, though, a lot of them are going to look for like ML scientists or like ML engineers. So they'll be looking for the same types of signals, which are that you possess some, relevant expertise. Oh, really, Invika? Yeah, yeah. I mean, that's why you'll see like a lot of these that I'm opening will tend to be like this kind of thing. World grounded image synthesis. Uh, okay. I did open a lot of NLP papers today, but it's because in the fact people are like, hey, why are we just reading vision? But here, like world model. Um, I don't know what this one is actually. World, and then we can grab some more in a minute. But anyway, let's get started, or I'll cover nothing, and that would be bad. Okay, let's grab my questions. Let's make them a little larger so everyone can see them. Let's grab my timer over here from the other screen, my little clock app. Let's pull that up on the screen, set it at 1 minute. Sorry, by the way, for no videos during the week. I'm in a bit of I don't know, I'm just working too much probably. And one of my kids had a science fair project this week, so spent a bit of time helping them with that, and just between like home stuff and work stuff, it's just spent very little time for the YouTube. Making time for the stream still, but like I would love to be editing out this stuff to like be posting shorts in the week or like some of the long form for the paper deep dives, and then I really wanted to start recording this history of computer vision series that we planned in the last stream, but finding the time has just been really impossible. I will though, soon, I promise. Okay, let's get started. I'll answer the questions after I've done a paper. Video object and interaction deletion. So I saw this paper from Netflix, well, a Netflix intern during the week, right? Where it seemed like the main idea was that you would identify an object in a video and remove not just the object, but all interactions with the object. So what if the red, pink, and green blocks were never there? What would everything else in the video do differently? And the thing that I noticed about it when I was reading it on the social media is that, and I'm not sure where that becomes clear when you're reading the paper, but it requires a lot of inputs, and I'm trying to see where they specify this. See, and this isn't fair. Normally I'm reading these papers blind, right? But this one I actually looked at quite a bit during the week. I'm trying to find where I can show you what they say you need to give them, because it almost looks text driven, right? But in reality, you need to provide it like here. Sorry, this is not like what I normally do for the paper speed run, but I'm trying to show you a specific thing. Where do they explain what they need for this? If I can't find it, I'll just tell you. See, okay, so here they explain it's quad interaction aware quad mask conditioning, right? So you need to provide this quad mask, and I believe you need to provide it like extremely densely. Let's go full screen. Sorry to anybody that's watching on vertical. Hopefully that's not any of you. Not because I don't want vertical viewers, but just I feel bad. Okay. So yeah, we need to have, okay, they're saying you can do it with a VLM generated mask, but you need this dense mask. You need the optical flow. Yeah, they're saying you can just VLM generate the mask. Online, I was seeing people say that it felt like the VLM mask didn't work so well, but I suppose they're saying that the VLM mask works. But you need the mask, like it's not like a one-time mask. You need it. I'm trying to find the frame frequency in the paper. But maybe that's a detail. Maybe the reason I was reading so much discussion about it is because the paper does not make it super duper clear. Anyway, and this also, like, video figures are always so tricky because I'd like to show you how the method really works, and I'm looking for a figure that shows it well. I don't feel like these completely convey it. This sort of does. Like, let's focus on this one real quick. So you have two cars that are heading towards each other, and they're going to collide, right? So what if the right one is just never in the video, and they're showing that their method gives a plausible trajectory for the car to do that avoids it, right? Whereas the other one just kind of keeps the car in the same place, or this one removes both cars. Theirs actually handles it. But it requires, what I was reading is just like an extreme level of like human attention to get it to really work in terms of like what you're masking out. I'm not really seeing them show that clearly in the paper. Aside from mentioning, like we saw the mask and we saw the optical flow here. We saw that it's kind of pricey, right? We have this 2-pass kind of thing. The first time we do the pass with the 1 mask, then the next time we do a pass with the optical flow as well, and warping the noise. What more is there to it aside from that? Is that really clear from the paper? Sorry, I started with like the catch, right? Which is that you need these masks. But what's like what do they actually give us in terms of the method? Aside from just telling us that it's like mask conditional or whatever. Because that's, I guess, the part that we're interested in here. Counterfactual trajectory synthesis. So it generates a counterfactual prediction, but how? Denotes the Gaussian diffusion noise via the video input sequence. This pass typically captures broadly the correct hypothesis, but like, what's the target here? What's the loss, or what's the... Sorry, I know it looks like I'm just scrolling crazy style, but I'm looking for equations that I expect to see, and for diagrams I expect to see, and they are surprisingly absent, to my view so far at least. Counterfactual dataset supervision, rigid body dynamics. They simulate collisions and structural dependencies, and then they create counterfactual videos by removing objects while keeping the initial conditions so that they can basically synthesize. Yeah, so it looks like they synthesize data with and without interactions to try to like have some set. This would make me think that you probably learned this via some kind of RL loss, but where do they describe the learning? I'm looking for that. Oh yeah, I forgot to. It's initialized on, it's on top of a cog video model. Is it a LoRa though, or is it second pass to fix the deformation? Sure, but where's the training? For each real world video, we blah 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 blah. We did not compare. Am I missing something crazy? Like, do they not train this somehow? A video object removal framework designed to perform physically plausible inpainting. New paired data set during inference. Okay, but where's the to train the model? They just to train the model we generate a paired data set, sure. But then what do we do? 2 improvements over work, quad mask, video appearance refiner. Oh, here, let's look at that. Okay, so yeah, the quad mask. So I talked about that already. They have that extra condition, but how to incorporate that condition and what's the loss? Video appearance refiner applied on a second. Yes, but that's like a new, that's just another pass basically with the same model. But how is this actually trained? That's what I want to know. We talk a lot about the data. What is the training strategy though? I know that it requires a data set. Wait, yeah, constraints, okay. Because they don't really describe it in much detail, huh? I'm not crazy, it's just not here. Yeah, it's not here. Okay, sorry, I wouldn't have spent so much time on that, but it was a viewer requested paper, so I wanted to be careful before I just kind of dismissed it, that it wasn't like, that I'm not losing my mind. It's certainly a cool capability, right? And we can even go and look probably at a couple of the videos. Like, it's very interesting. It's kind of funny too. It's infilling with things that could be on that counter if the blender were not, which is interesting. Oh no, if the person were not. Oh no, sorry. That thing really is there. Okay, so we haven't had to come up with anything crazy because we see basically all that stuff that would be behind the person. And yeah, so the cool part here, and I talked about it when we were looking at the paper in the first place, the thing that people are excited about is it doesn't just remove the person, it removes the operation of the blender because there's no person there to operate it. See, blender on, blender off, with and without person. Do they give us more videos? Any other cool interactions to see? Oh, so the first pass would really struggle to know what to do with the ball, whereas the second pass gets it looking better. It's stuttering a little bit when it necessarily maybe wouldn't in reality, but like it's decent. Okay, here, I'll catch up with chat now. Okay, what's your advice for, oh no, I already answered that. Not recent at all, but I read DPS recently. Here, post the full name of that, Invika. I'm not sure off the top of my head what you're referring to. I'm interested for applying to PhD. How many papers at top conferences would make you super competitive? Sorry, I know this is random. Okay, so top PhD right now, it's a bit harder. If you want to be super competitive, probably 2 first author top conference, I think, would make you super competitive. And 1 would put you, like, on the boundary. In both cases, though, the letters might matter even more than the papers, but the papers are good for getting you like looked at. The letters are going to matter a lot though. So can I publish the paper after CS229 as the final project if it is really the problem that can be solved for CS229 knowledge, or should go for applied projects? After CS229, you are probably not going to have the knowledge to do anything that's truly on the cutting edge. Probably. However, maybe you actually would have enough knowledge to go for like the kind of workshop style projects that we talked about last week, or like challenges or like Kaggle stuff. And those can be good for like workshop papers or technical reports. It just depends. It depends. Some people could totally do CS229 and then maybe be educated enough to read papers at the cutting edge and then come up with like a top idea. It really just depends. It's hard to say. I would say looking at it in terms of just writing a paper is not necessarily the best way to look at it. And I know that that sucks because that's the thing you want to do. And it's sort of like vapid advice to just say, oh, don't try to write a paper. But if you are only looking at it in terms of getting a paper, you might compromise the science and then you won't have something that's actually worth writing a paper about. Is it worth learning AI now? It's too late because everyone is doing it right now. So many bootcamps classes, it's exploded now. Should I look for other emerging technology that haven't become maintenance now? AI is definitely not at maintenance right now. Granted, it's hard for me to say what it'll look like in 5 years. And that's tricky because anyone that I'm telling start a PhD, it's kind of like, what's it going to be in 5 years? I don't know. If you start a PhD now, though, you have the opportunity to shape it. It's not like you don't get into it till you're done with the PhD, right? The PhD is actually jump in right now and start doing cutting edge research in it. Still definitely a great time for that. For language model folks, I know that some of the bigger problems revolve around continual learning, or maybe how can we get away with not knowing continual learning. For those of us in vision, I think a lot of us are really bothered by the fact that our stuff doesn't scale. 3D was brought into the domain of neural networks, and now it's out of the domain of neural networks again with stuff like Gaussian splatting. And Gaussian splatting is pretty hot relative to vision. World modeling, obviously. Not just generating videos that look good, but the idea of like, can these be the things that are the robot's brains, basically, that will help them predict the future? And then you have the debate, right? Like LeCun versus Jing. Is it all about compression, or is it all about like faithful reconstruction? And what do I really need to know in order to model the sorts of futures and the sorts of interactions that I need to have in order to drive a car and pilot a robot and do things like that make sense? So these are all very, very active questions, and I would say nothing is at maintenance right now. Diffusion posterior sampling for generally noisy inverse problems. Maybe we can look at that. Depends. For sampling for generally noisy inverse problems. Oh, this is like a... Oh, okay. Older paper. Maybe we'll look at it in a little bit. Yeah, that's an older one. Okay. Let me line it up real quick. I won't look at it right this minute. We have a couple other papers to look at first, but I will look at it like before some of the other ones maybe. Okay. Let's start moving through this. So we had 2 viewer-requested agentic papers. Let's try to see what they're trying to do. Okay, so this first one is about image generation. They're saying that image models are constrained by frozen internal knowledge. So GenSearcher tries to train a search-augmented image generation agent, which it looks like we're trying to bring basically RAG type of ideas into the image generation, right? So multi-hop reasoning, search and collect textual knowledge and reference images for grounded generation. I want to see the diagram. Oh, and we're training it with some RL, I saw. SFT, and it looked like it said some GRPO, which means they're going to have some backbone, right? I guess we'll look at what the backbone is. Okay, so the previous paradigm would have a prompt, an image generator. Theirs does a lot of search and then an image generator. I want to see the kinds of conditions that theirs takes because it looks like they would maybe give theirs some image prompts, right? Can we see like what kinds of inputs we're taking to the model? Oh, or okay. Do we finally have a prompt that just describes? No, we can give reference images. Okay, so we can give a prompt images, so it's like this integrated like text image input, and then we'll get image output. So I bet the backbone needs to be one of these interleave text image models anyway, which is true of some of them, but not all of them. So yeah, Chum1 image, CDream 4.5. Wait, what? Oh yeah, I guess those, so they can pass these to the models that are even behind the API, right? Because these aren't open weights models, these two. GenSearcher 8B. Hold on a minute. What's the division of parameters here? Why would the GenSearcher be 8B separately from, okay. Oh, because it's a VL model. Oh, so they tune the Chum1 3 VL to generate this. And then they pass this over to one of the state-of-the-art models. Cool, that's neat. These scores look better, right? Like we need to look up, by the way. These are where the state-of-the-arts are. So we can look at Chum1 image here, and we can look at like Nano Banana and CDream 4.5 here. And I'm doing a bit of cross correlation. We improved the score by like 3. They improved the CDream 4.5 by a lot. The Chum1 image, they improved by a lot. Do they have any cool demo? It's an interesting idea. And I think one of the interesting ideas is it's more about just constructing a good prompt for the model, which already generates good images based on text and image, and you just have to give it the right images and text to get it to generate the nice image. Do we have any like really nice examples that sell this? We can zoom in. Generated images on there. Oh, and they propose a benchmark. Oh, hold on. Was one of these their benchmark up here? This wasn't, right? It's just, it starts here. No gen. Okay. Did we have that in this table? Oh, this is their, okay. So this was already their benchmark. Cool. So they proposed the method, they proposed the benchmark. The benchmark requires knowledge. These are some examples. So the original prompt would be a professional portrait of some, oh, I see. So this requires the multi-hop, right? Because it's not telling you who the architect is. So to give the picture, the model has to be able to do the internet search to look up like who won the Pritzker Architect Prize in 2024. Seated in a minimalist Yokohama studio. So if that's not already in the model's internal weights, we maybe search for a reference image of a Yokohama studio. A nameplate must be correct, showing his full name and the official English spelling. So maybe if you look him up originally, it would show like maybe just Japanese characters, and so you want to get the English spelling of the name. Monogram of his work, spine clearly displaying the name of his first major housing project. Okay, so this is even more hops, right? We need to find the guy that won this award, and then for that guy, we need to find the name of his first major housing project specifically. And once we have the name of that, we need to find the year that it's finished, and we need to display all those things, right? And it's showing how naively these models would actually try to show things that are like somewhat plausible, but wrong, right? Just wrong. Whereas when you add the GenSearcher to it, get the reference images and stuff, and get the reference info for these other things, then we actually have it correct. And I think that's a pretty cool idea. It's a paper from Keist. Sorry, it's mainstream, not maintenance. Yeah, Coding by Sammy, it is mainstream. It is mainstream right now. And so there's two ways to look at that. You could either say it's really saturated and I'm scared and I don't want to go into a field that's going to be really competitive. You could also say, what if this is the top and it starts going down? Those are both valid thoughts to have. On the other hand, if you always avoid things that are hot, unless you happen to be right about the next thing that's going to be hot, you're just going to be doing things that are less popular. And whether that works for you or not, I guess depends on you. Okay, deep breath. Cut claw, agentic hours-long video editing via music synchronization. Okay, so we're going to edit this based on music somehow. Music-driven video editing system that transforms hours-long footage into high-quality short videos based on user instructions and given music rhythm, so that the resulting video demonstrates precise music sync, faithful instruction following, and visually appealing aesthetics. I feel like I'm not going to get what I want from the paper because I almost just want to see the examples, because from the text it's hard for me to understand exactly what they mean to do. But the multimodal footage is first deconstructed, and then the shot plan is generated by the playwriter, scene retrieval by the editor, and quality validation by the reviewer. And then do we kind of repeat this a bit? Like we can go back and forth maybe. Yeah, we get scene level captions. We get the music structure, and we take the instruction. The playwriter has to handle all of these. Okay, man, these are lots of different components. They perform the shot detection on the entire video and conduct a caption for detailed understanding. Then an LLM aggregates similar content for scene level description. Then the playwriter generates the whole storyline and gives a detailed shot plan. Oh, that makes me think that the point of this would be like to take a movie and to try to get like, hold on, is the audio from the video or is the audio separate? I think that the audio doesn't come from the video, which is the big thing that I missed originally. We would get like, I know what this is now. This is like when you're doom scrolling TikTok or YouTube Shorts or Instagram Reels, and you get like the Batman The Dark Knight in 30 seconds with like some really catchy music that's not from Batman originally. It finds like the perfect moments, and I suppose some instruction too, right? Yeah, you can basically say like, I want a crazy edit of the Joker, except maybe you give like more instructions than that, and then you give the whole Batman The Dark Knight, and then you give like your little like music that you actually want to sync to, and then it spits out the whole video. So this is like basically automating slop really, really effectively, right? That's cool. Um, I don't know how I feel about the whole genre in general of this kind of short. It's funny. I actually have a friend who like he says he doesn't watch movies anymore at all. He just watches the 5 minute like these style of summaries where like it's the new kind of music and just all the things condensed into like the key parts of the movie. But that's essentially what this is, right? We have we're going to take the audio and we're going to process get the structure. We're going to tell the playwriter the structure of the audio. We're going to tell it what happens in every part of the movie, and then we're going to tell it the instruction. It's going to pick like the parts that it thinks have those things. The editor is going to make the actual shots, and the viewer is just going to say like, does this look good? Does it like actually match what the instruction is and the things that we're supposed to do? And then maybe it iterates a bit on that. Seems pretty straightforward. Seems like content creators will like it a lot. This is ECCV format. I'm extremely curious how the ECCV reviewers react to this. Because like obviously it's not the first method ever to do it, right? If we zoom in, like there's existing benchmarks and a few other methods, and this one destroys them all, right? I would be surprised though if these use all the same things, unless maybe this is a task that was established by one of these papers, right? Where you take the prompt and the video and the audio separately and synthesize them. Interesting task, I guess. Crazy though, because I wonder are you actually using real movies in this and just kind of ignoring the copyright issue? And like they're even showing like, I would really struggle, I think, to get approval to even put this at the top of a paper. Just because it's copyright, right? I would be worried about getting like copyright strike by any of these groups. But anyway, interesting. Let's look at chat. Okay, so what's your perspective about quantum plus AI? Should I also look towards quantum technologies as undergrad and learning AI? I don't know. I'm not the biggest quantum optimist. Google is definitely signaling that they think they have big things going on with quantum. I think they said they're going to quantum harden their whole stack by like 2029 or something, which is crazy. Actually, we're streaming. I should just show you all the PR. Like what is Google saying about their quantum? Yeah. Quantum frontiers may be closer than they appear. VP Security Engineering, Senior Staff Cryptography Engineer. Google introducing a 2029 timeline to secure the quantum era with post-quantum cryptography mitigation. And I think the year that they're putting on like some kind of scary capability is 2030. This is some blog. Q-Day just got closer. Where like certain RSA encryption is just obsolete. Yeah, NIST's deprecation timeline calls for quantum vulnerable algorithms to be deprecated after 2030. Maybe quantum is exciting. I don't know. Feels like mostly quantum is just going to be really useful for stealing money and passwords, and maybe totally destroying Bitcoin forever. I don't know. If you're into quantum, do quantum. I wouldn't say just do quantum because you're like, oh, this is hot. I also wouldn't say do AI just because you're like, oh, this is hot, right? These are very deep, complicated subject matters. They're very tricky. They're very competitive. They take a lot of time. It's important that it's really what you like and what you're interested in. I would caution against just chasing it for money because I think that becomes exhausting. But it's up to you. I don't know. With quantum, I feel like you're kind of taking a bet. It's definitely the kind of thing that like a lot of people want to make be a thing, but is it a thing right now? No. Um, and will it be a thing in 5 years? Hard to say, right? Like I mean, you can look like, did this make it to the news? One of the bigger groups, yeah, here we go. Like one of the big labs went from like 500 headcount down to 125. Oh my goodness, I didn't see this. An employee of the research company was sentenced to. Okay, well, we're on the daily news. Let's maybe see if we can get a little more reputable. Um, yeah, so this is a big quantum lab, and I think they basically laid off like, does it mention quantum in the article? They basically laid off like all the quantum people because they lost the federal funding. And so I don't know. It's kind of feels like I'm not sure how much the federal government prioritizes quantum at the moment. Obviously, you still have some companies that do some startups. You have Google that does. But where does that go? I don't know. But do what you like. That's my broader advice. Do what you like. This cut claw is a peak brain rot thing. Yeah, it is funny. I still regret. Why can't I be able to get into AI in 2016? How to spot the next big thing? Okay. I don't have great advice if you're just trying to spot the next big thing. I got into it because I like it. I would say do stuff you like, and if it becomes the next big thing, great. If not, make it the next big thing. I don't know. What can I do as an undergrad trying to get into a lab at UMD? Oh, UMD specifically? Do I need specific qualifications before applying to a lab, or should I just apply? Feel free to just email professors. It depends. If you tell me your year, I can give you very specific advice. Um, yeah, like the younger you are, like getting into honors should give you specific research opportunities. That can be helpful. There's some freshman program I can't remember the name of that could match you with somebody specific or get you into like a big cohort to do interesting projects. There's obviously capstones that are supervised if you're a senior. There's research for credit at any point in time, but you have to find a professor first. So you can try emailing professors, you can try emailing PhDs. The good thing to do is to try to take their courses, their senior level undergrad courses a little earlier, like try to take them sophomore year or junior year, talk to them, be active in the class, do well on the project, and then once you establish some kind of small relationship, it's a good time to ask them those kinds of questions. Uh, it's funny, I'm getting notifications on my main monitor about my friend's Steam activity, which I could have sworn I muted that. I'll figure that out after the stream. Those are all things to do. You're a sophomore? Yeah, as a sophomore, if you haven't already taken the courses for what you're interested in doing research for, make sure you're enrolled in them for next semester, and you can start trying to build those relationships with those faculty. Um, and then, maybe midway through the semester, as you feel like you've made a good impression, done well on their midterm, is a great time to start to ask. You can obviously ask before. It's just you're going to have a lot more luck if you're someone that you've already showed them like, hey, I'm competent, I'm participating in the class, I'm interested in this, and I'm doing well. Those are all good things. Okay, let's look at this paper, and then we'll look at my friend's paper. Let's set the clock. Diffusion posterior sampling for general noisy inverse problems. This is an older paper. It's not a newer paper, but a viewer specifically asked, so let's take a look. Yeah, this is one of the older diffusion papers. It is showing a few different capabilities, like the reconstruction results and the deep blur. And I'm trying to remember, did I see this paper at the time? They propose a specific posterior sampling method. Man, this is a rough candidate for the 1 minute. I'm going to try to go straight to the result, and then I might come back to the method a little bit. Conceptual illustration of the geometries of two different diffusion processes. So their method prevents the sample from falling off the geometric manifold, and measurements are noisy. What they're showing is that the older paper, which ironically I'm pretty sure is their paper. Yeah, it's their paper. But what they're basically showing is that you want to basically get onto this blue line, and the earlier approaches would often kind of jitter around and could ultimately fall off of the line, whereas they have a more stable way to sample the process and stay and like get to the blue line. Describing it that way feels really dumb, but that's basically what's being shown. And all these tasks are basically your typical suite of image restoration methods. You have your super resolution, which is where you try to take your pixel count. If it's like a 224 by 224, you would be upsampling to like it's a times 4 here. 256 by 256, you go to 1024 by 1024. In painting a box, can we find a visual example here real quick of these tasks? Here's the super resolution. deblurring. So like you take a blurry image trying to get to the deblurred image. Same with motion blur. Where's the box in Paint? I don't want to describe a box in Paint because I can just show you if they have it. It doesn't look like they show the box results though. A box in Paint just means you put like a square thing, like a square box on the image, and then you pass it to the model. The model should remove it. In Paint random, I really need to see an example of what they do to know what they mean by that. Because to some extent, if they're literally just masking random pixels, that's not necessarily meaningful. Oh, I suppose that is what they're doing. Okay, so it's sort of like a noise removal task at that point. What are the other tasks that they can do? Yeah, just the deep blur, the Gaussian and then the motion, right? Two different types of blur, right? Because the Gaussian blur is sort of, it's not uniform, but it's spread across the image, right? Whereas the motion blur will often be very concentrated on the object of interest, or it will be caused by the camera motion. So two different types of blur. Let's try to look a little bit at what the method actually is. If I can grab any of the math for you on stream. Let's see if I can find the relevant math. Okay. I might need to glance at their notation really quickly in order to get this. Let's see. Okay. Okay, that's how we're defining it. Okay, so no analytical formulation. So in order to exploit the measurement, they factorize this as follows. Integral over p of y given x sub 0, p of x sub 0 given x sub t, d of x sub 0, where the second equality comes from the fact that y and x sub t are conditionally independent on x naught, shown in figure 2. Okay. Are they independent? Is that true? Yeah, I mean, obviously it's true. Okay. Can I do a good job with the math paper in the format of the stream though? Because this is normally the kind of thing where like I pull out a whole sheet of paper and then I'm going over, like, what's the thing I want to tell you about this? I don't know. That's why I tend to lean towards things where we can see like a good diagram. And maybe that's the level to stick to it with. But the thing is, like, I can go to this figure, right? And I can show you that essentially what's happening is we are taking like smaller and better steps to basically move from, like, these are both starting at the same noisy point, right? And across steps, we want to move towards like the correct clean image. And every time we take a step, we don't know what the clean image is, right? We've only ever seen the noisy image. And so what your sampling process does is it says, based on the prediction of the network, what kind of step should I take? And if we take steps that are too big, we'll end up like veering potentially far enough to where we get to these unrecoverable points and then we can't actually get to what the correct clean image would have been. But man, explaining it from all this math on stream, tricky. I'm trying to think if there's a good way. I don't think there's a good way. I think I'm gonna move on. I think I would need to prep. Because with a lot of these early diffusion papers, it was before a lot of the notation like became uniform, and so you can spend a lot of time just trying to, like, you'll need to go through their background even though you know the background just to see how they're using the symbols, and then there's a lot of scrolling back and forth. So not necessarily the best like stream paper. I don't know. The short of DPS is just replacing the prior score with the posterior score, which is just prior score plus likelihood. Here, we can go back to it and I can point out where that part is, I guess. Diffusion, posterior sampling. Here, that's even explained here. So their method demonstrates that diffusion models can incorporate various measurement statistics. Okay. Handle general, noisy, nonlinear inverse problems via approximation of the posterior sampling. Interestingly, the resulting posterior sampling scheme is a blended version of diffusion sampling with a manifold constrained gradient without a strict measurement consistency projection step. Oh. I see what they're actually saying here. We can go to, it's their own prior work. Let me find the link to the paper real quick. Or maybe they explain it here. Let's try to see where they show it here. Okay. So the key is replacing this. Let's see if we can show exactly what happened in the prior work, and that's going to make it a lot more clear what the special thing that's happening here is. Okay, so wait, how did I? Man, okay, sorry, that's not what I wanted. I thought I copied this, yeah? Improving, yep, improving. Okay, cool. Okay, so this is their prior work, their own prior work that they're building off of, and this had, like, in order to try to make the correction, they rely on a projection step. How do they compute the projection? Even this paper, wait, what? We're in the right paper, right? Oh, is the projection step not even okay? So their prior work did not propose the projection step. Their prior work, even this one proposes a correction on the projection step. Let's see, what is that original projection step? Because I've never worked in this diffusion like recovery regime where we're intentionally injecting other kinds of noise into the process to like deblur an image or super resolution image or remove a box from an image. Oh, was it still one of their? No, it can't be that one. That's like pre-diffusion, right? Is it this paper? Stochastic solutions for inverse linear problems using the prior implicit as a denoiser? Maybe. Let's see. Here we develop a parsimonious and robust generalization of these ideas. We rely on classical statistical results showing the least square solution for removing additive Gaussian noise can be written directly in terms of the gradient and the log of the noise Z signal density. Stochastic course-defined ascent procedure for drawing high probability samples from the implicit prior embedded with the CNN trained to perform blind denoising. Perfect. I believe the projection is going to be this then, right? Let's see. Let's see if we can find the clear part of the formula where they do that. Drawing high probability samples from the implicit prior. The implicit prior is universal blind CNN denoiser. They compute the gradients, and then each iteration operates by taking a deterministic step in the direction of the gradient and injecting some additional noise. The effective noise variance of image y sub t. Let's see. Can we get to the final? Where's their actual final? Okay, here we go. Course-defined stochastic ascent method of sampling from the implicit prior of a denoiser using denoiser residual f of y equals x hat sub y sub minus y. Real quick, the network itself, the CNN is defined as it's f, right? F is our CNN in this case. No, f is the residual of the denoising function. F is the residual of the denoising function. Oh, which in this case the denoising function is our blind CNN denoiser, right? Hang on, I need to make sure I'm not messing up my notation here. Real quick. Y is the noisy observation. F is our CNN, right? I just want to make sure I'm not, because if I'm bungling the variables, I'm going to be totally thrown off here. Or is H sub t? See, where do they define H sub t? Because ultimately I'm taking a block diagram in figure 6, they say? Okay, let's go to figure 6. I like diagrams. This might be in the appendix, but that's fine. Fine with me. Let's go to that. Then I don't have to wrestle with their... Oh, please. It's in figure 6. Okay, we got to go to the arXiv version of this. which has figure 6, I suppose. Oh man, this is not okay. I feel like I've stumbled. I feel like this is sort of defensible, right? We've gone to the prior work and we're at this like 100 citation paper from before diffusion had really taken off for image generation. And so I am on the struggle bus right now. Oh my god, where is figure 6? Help. There's a block diagram they promised. Oh, here it is. Okay. Sorry, guys. Sorry, everybody. Sorry, folks. Guys and girls. Okay, so... Oh, does this even help? Okay, block diagrams for denoiser training and universal inverse sampler. Top, a parametric blind denoiser. D. D. Here it is. Is trained to minimize mean squared error when removing added Gaussian white noise. The trained denoiser parameters theta constitute an implicit model of this distribution. The trained denoiser is embedded within an iterative computation to draw samples from this distribution, conditioned on low dimension linear testing. Oh, so wait, this would have been like this is the only model involved. So it's kind of like we're doing the diffusion process with this CNN that we trained as a blind denoiser. So then when I'm going back to this is the projection that they would have done in this process. Where does that come from? I went through all these papers to try to understand where that comes from, and I'm no closer to understanding where projection comes from in the process. If a chatter wants to save me and just tell me where the projection step comes from, that would be awesome, because I'm getting my ass beat right now. Sorry. Oh man, this is what I get for trying to understand things live on stream. I hate it when this happens. Okay, projection step. Please just tell me the mechanics of the projection step precisely. I don't even care if it's math. What network does it come from? In this method, it definitely comes from the bespoke denoiser that we train. That's just gonna take the noisy image and then make some prediction, and then we're gonna measure the residuals to take steps in the right direction, which is essentially what the diffusion process already is. So I'm having trouble understanding when I have a defined denoising process. Why was anybody taking extra projection steps in the first place? That seems odd. I mean, because basically all this method is saying, like, if you look, like, we're essentially, like, this step is the same, right? The step didn't hardly changed. The formula, exactly the same. The only real difference here is we don't do the projection and we're able to just rely on our S sub theta star and our delta X sub I. Y. Like, that's the difference. Man, I'm really not grasping the exactly how this projection was computed, like, once we brought the diffusion denoising model online. Or sorry, I guess it's not still a diffusion denoising model, right? What actually is our model? I'm making bad assumptions. This is an earlier paper. I should see, like, what's the... Okay. What's the model? Okay, the pre-train... Yeah, so they take the Dari-Wall and Nickel diffusion model. So the old diffusion model. And... Oh, except for FFHQ, they train it from scratch. So they are training a diffusion model from scratch, and then applying their Gaussian or Poisson sampling method. Which one do they end up using, actually? Is it the Gaussian or is it the Poisson? Because those are both defined a little differently. They have different assumptions, right, about the distribution of the noise. Does that mean do we match those to different types of denoising? Where do they say that? Where do they say which one they use for which process? They can handle both the Gaussian and the Poisson measurement noise. Right, because they have two different processes, right? One using the Gaussian, one using the Poisson. So where do they say which tasks use Or are they always doing both in parallel? Here they use the Poisson noise. Do they show using the Gaussian noise? Yeah, they do. Phase retrieval, non-uniform deblurring, Gaussian deblur. Does this mean these tasks would always do Poisson, and these tasks it would always be the Gaussian solver? Probably. That'll be my assumption for now. I think that's a fine assumption. I think we spent long enough on this one. We can jump to other ones. I've made myself suffer enough. The project is the likelihood, you think? Okay, interesting. The likelihood is different based whether the noise is Gaussian or Poisson, which changes your sampler to my understanding. Okay, so it is like, but just based on the, do we reopen the paper one more time? Why not? So we identify which type we're going to need to use, which they show us some examples in these figures. So the non-uniform deblur would be the Gaussian noise. The Gaussian deblur would be the Poisson noise. I guess that makes sense. You just spam Bayes' then throw the new score function into the SDE. That's what it seems like to me. Control-Shift-T reopens the closed tab. Oh, thanks for the hotkey, Arena. And then just solve that. Yeah, that is what it looks like. I mean, it just strictly makes it simpler, right? We take, we basically just have the two steps instead of having the third step, which is like the bad assumption, which actually, I mean, to do a very hand-wavy thing, sometimes this is a very large step. And the point of this step was originally the assumption was that you always wanted to try to recover onto like the true correct trajectory or whatever. I guess the idea being like try to remove all of the noise quickly to be on whatever that like clean image is. But that's like a bad assumption. It's too big of a step to take too early, and it's better just to move there gradually. I think that's how to explain the vibes difference in the methods. It's like, do I need to try to recover early all the time, or is it better to just stay like on the correct manifold for the step that I'm at and just make all my steps that way? And I think obviously the latter works a little bit better. You have to spend some time tuning the weight of the likelihood. Yeah, that's what I was seeing. I think they even gave a chart where they show varying them, right? Where they vary some of the parameters a little bit. I thought I saw that somewhere. These are some of the lemmas and the theorems, which is what I would read, obviously, if I wanted to really understand this. No, that's not where they actually vary any parameters. Yeah, there we go. So step size, for example. You need to tune the step size just right in order to get the result that you actually want to get out of the method. Where's the input for this one? That'd be kind of helpful to see. Yeah, step size again. So we can see the effects of the different step size. And we can see that some, like, obviously if you do a crazy step size, you get like a crazy bad result on either end. Like you change the identity completely if the step size is incredibly small, or you just fail to remove the artifact or introduce new artifacts if the step size is very, very large. The whole thing falls apart, I think, if it's a blind inverse problem. We don't know the forward operator A. By blind inverse problem, you just mean that we don't know, like we don't know if it was a Gaussian blur or if we're doing super resolution or if it was a square box, right? Because we have to know whether we're applying the Gaussian or the Poisson, and we have to roughly know, do we have to know the magnitude always as well of the degradation? We always kind of would for super resolution, right? That's the nice thing about super resolution, is we do know the forward operator. But in the case of like real blur, we wouldn't necessarily know. Motion blur, we can make some assumptions or even take some measurements. Anyway, interesting paper. I got to do like remedial maths or something. I did such a poor job of that. Sorry to everybody that had to suffer through me suffering through that paper. Anyway, this one should be more empiric, so I'll do a better job. Deep breath, and I'll catch your question in a second, Hassan. Or okay, is your name Hassan or is it more like Hassan? If you can hear the difference between what I'm trying to say. Hassan or Hassan? Efficient universal perception encoder. So they want to have an encoder with a small size but powerful and versatile representation. They call it efficient universal perception encoder, or UP maybe. Unlike previous agglomerative methods that directly scale down for multiple teachers, they demonstrate the importance of first scaling up to a large proxy teacher and then distilling from that teacher. So this actually reminds me of the DynaV3 idea, right? Train my 7B model, but maybe never use the 7B because it's expensive. Instead, distill it to like the 1B, the 700M, the 300M, etc., right? It looks like they do well on a host of benchmarks. One thing that immediately pops off the page to me is we're not just doing well on the semantic task, see there the red, but we're doing okay on even like the text-based tasks. So that means we can do the understanding with the text while still doing like the image level semantics, which is pretty cool. Like not a lot of papers can do that super well. So it looks like we distill multiple teachers to a large model. Then we go down to an efficient student. How efficient do we get? VITB, those are really good VITB results. So I covered these things in the minute. Proud of myself. I kind of knew the paper a little bit before though, so don't get too proud of me. I waited to read it though till the stream. I vaguely knew the idea, and I'm scrolling for something very specific now. They have a VITS. They also trained the VITT, which PE Core also did. And so let's zoom in. That's one thing that I'm interested in seeing is where do they beat PE Core T? Now, what I noticed just from looking at the radio plot actually, or the star chart or whatever, is PE Core is outperforming them on text VQA, right? That's the yellow line. And SIGLIP obviously is outperforming them on the text VQA. Although GQA, they get the best result, and Pope they do too. That's interesting. But anyway, so PE Core might still have some advantages on the text task, some of them. But they've really got good numbers on all these image understanding tasks. So let's go look at the numbers closer with that in mind. So especially they pitch efficient, right? So they're trying to sell themselves around this VITT and this VITS, where it looks like on the image understanding, depending on whether I do the classifier or the KNN, for the classifier, the T's better, for the KNN, for the classifier, PE Core is better, for the KNN, they're better. For the text VQA, it's PE Core, for the SQA, it's VITT, or sorry, it's UP, which is interesting. So I guess maybe OCR is a little weaker, but the knowledge is good. They do well on the vision tasks, way better on the dense prediction, right? These are crazy differences. And this is a really, really strong result for a VITT. And for a VITS. I mean, these are better than what the SOTA state-of-the-arts were a couple years ago, even for like the VITB, right? Even for, there was a time where we weren't getting this good of performance, even like fine-tuning the MAE VITB. This is a really good result to get on the dense prediction, although I will say I'm actually not sure if they did it linear probe. I saw these numbers and assumed linear probe. Obviously, if they're fine-tuning the system, that changes what I'll say. So do I want to spend the time to see which one they're doing? I don't think I care right now. Too much. Do they do any conv nexts? Yeah, they do. Yeah, DynaV3 does some conv nexts. This is a meta paper, so they did some conv nexts as well. Those results are pretty decent. I think maybe the conv next T runs a little faster than the VITT, and that's sort of the point. But these are good numbers, even on the text task, which is pretty cool. How does it actually work? I think I said the main method at the front, right? It takes the AM radio idea. If you can even say it's the AM radio idea, I mean, like a lot of papers have probably had the same idea, take a lot of teachers and distill them into one model. And then they distill that model into all their students, right? First at single res and then at multiple res. The point of the multi-res is, especially when you're talking about some of those dense tasks, you're going to want to operate for like the NYU, you're operating at 480 by 480. For the 8020K, maybe 512 by 512, and then eventually variable size image even. And so you'll need to make sure it can handle the different resolutions. Rope gets you part of the way there, but then actually seeing some of those images helps you finish figuring out how to do that. Interestingly, it looks like their teachers are just like PE Core, PE Lang, and Dyno. So no siglip teacher, which surprises me. I'm not sure what they actually propose in terms of the loss itself. I think I'll glance over the other diagrams and maybe look for equations. So the student has patch tokens, has CLS token. The teacher gives patch tokens and CLS token. I'm going to pass on the student side all my tokens through it looks like a patchwise adapter and a class adapter. I'll do some 2D interpolation. Why do I need to do 2D interpolation? Oh, because my student could operate at a different patch size, I think. I bet they say that somewhere. Like, I bet they're even doing, like, some 32 patch size, maybe, and distilling it from a model that does, like, Oh, they run all teachers at the native resolution. Okay, so, like, the P core would be 448. So they'd be interpolating regardless if they keep the teacher's native patch size as well, right? So they'd have to do some interpolation to get the patch size. It looks like they do the interpolation on the student side, though not the teacher size side. So if the student is like a patch size 32, they're interpolating that up to get to the size of the teacher. And then there's some normalization on the teacher tokens, and then they get the patch loss. The class loss, it looks is a little bit easier, but that's interesting to me because, like, if you have a smaller model, your class token is going to be smaller than the teacher model. The weird thing about AM radio is they actually say that your, like, model that you're distilling from all the teachers should have, like, a really large class token. When they distill from 3 teachers, they make it whatever the token dim is times 3. So, like, it's a 2,304 dimension token instead of a 768 dim token for the VITB. I doubt that's what we're doing here. I bet we're keeping the native size, and this adapter probably projects it up to the size of the CLS token. I want to look at the definitions of the adapters real quick, though, if I can. Let's see. 2D interpolate the smaller one to the larger size. Yep, I was right about that. Called it. Losses. Where do we define H? Help me out here. Come on, Suxum. Where's the H? Suxum is my... This is my friend. Which maybe means this was his intern? I don't know. I should ask him. Oh, wait. Are they an intern? I shouldn't just say that. I should look at what the star is. I just saw many... No, probably not. Yeah. Full-time. Sorry. I should think before I speak. That can be like a sensitive thing, right? Yeah, core collaborator though, right? It looks like these were the 4 core contributors and then probably some manager, right? Yeah, I saw 2 different affiliations and that made me immediately assume internship, but it's actually just 2 different affiliations within Meta, right? Oh, interesting. This is I'm going to search before I speak. Again, because I should. Were they? Yeah, this was one of the core contributors on Dyna v3. I was right. Okay. Core contributor on Dyna v3. Anyone else from Dyna v3? Did I see Seitzer on both papers? No, I didn't. See, think before I speak, right? Look before I speak. Anyone else? Yeah, Piotr. Okay, so they collaborated a bit with it. I think this group's in France, and I know this group is not in France. So that it might have been some cool international collaboration. And that also explains why it's so... I mean, a lot of this is very reminiscent of Dyna v3 stuff, right? And that's not crazy surprising. Anyway, I think it's a neat paper. I think seems like a pretty slick model, right? What did I say I was looking for? H. I want to understand how they define the projector, because I think that's the only thing we don't know in terms of how they do the distillation, right? Is how are they defining this projector? How is H instantiated? Adapter heads for class token and patch tokens for the ith teacher parameters by whatever. The adapter class token and patch tokens for the teacher to match. Nope. Oh, here's the distillation loss, though. Okay, they introduced them below. Okay, so the class token loss is cosine similarity. Basic cosine similarity, that's it. The patch token loss is, I was going to say cosine MSE, but it's not MSE, it's actually an L1. That's surprising. When I did my distillation in my paper, I found that, like, cosine would be a bit more stable, but if I was willing to sit there with hyperparameters and just tune them all day, the L2 would work better. But L2 is typically better than L1, so this surprises me a bit. What's this L smooth? Am I crazy? What is... Should I know L smooth already? I see this L smooth suddenly. Where is this from? Oh, and I don't see a weight here, so it looks like all teachers are equally weighted, which the only reason this surprises me is that sometimes when you're distilling from like a siglip, which they aren't, but like you can end up with different magnitudes on your tokens, and so your losses can be like higher or lower per model. And so it's important to control for that, and I don't see normalization here. I do see some weighting on the cosine loss, but the cosine loss doesn't need weighting to correct for like norms. Oh, they do. Oh, I think they're calling the L1 loss L smooth, I guess. It's just the L1. And they do have this beta weighting on the L smooth, so I suppose you can control that. But are they controlling it per teacher, or just like, is there a global beta? How many hyperparameters do I have to tune? I wonder. I still don't know how H is actually instantiated. Is it just an NMLP? Does it have like a quick norm? I do want to know. As a guy that was doing this a few months ago, that's something that a detail I'm actually interested in. Where is it? Do y'all think they actually give it in the paper? I can just ask Saksham, I guess. Oh, and they actually follow the recipe in the AM radio paper series. That's cool. I feel like the AM radio series doesn't get enough love, right? Like, check this out. This is a neat paper. Only 55 citations. And like, it's an open model. You can download this thing and it's pretty powerful. It's only like 1.7k stars. I bet if we go, actually you can't see all-time downloads on Hugging Face. But I don't know, I just feel like this whole series, this is 1.7k stars for the whole series. And at this point, it's 2 CVPR papers and like 4 sets of open models. Okay, the one thing I wanted to see is, not PE Core. Can I download this model now? And if so, how many downloads does it have so far? Oh, it hasn't gotten a lot of attention, really, has it? Or did they barely put, is it not here? It's not. It is here. Interesting. I'm surprised that the launch has been a bit either. Oh, downloads aren't tracked for the model. Okay, so maybe it's just not, or maybe it's because I'm not logged in that I can't see it. I'm not logged in on this profile. But the upvotes aren't too high either. I don't know. It's just a little surprising. I think it looks neat. Especially if you need like a smaller model that's still like very, very powerful for a lot of these tasks. Anyway, sorry, I've been neglecting the chat like crazy. Thoughts on autonomous research, auto research. Okay. Oh, I did have a new thought on autonomous research. I think, oh, it's Hassan? Okay, cool. So my thought that I had this week was, like, a lot of people I think are obsessed with like how to use the auto research to like maybe do my hyperparameter tuning for me, which could be nice if you can find a way to constrain the hyperparameter tuning well. I think it would be kind of neat to use it to quickly, like, let's say that I'm at a group that's never done an image generation model before, and now I have one, and I need to like know if the performance is good, and I need to write a paper and prove that it's good, and I know that people are going to want me to compare on like all these data sets for all these different metrics. Can I just have an agent set that up? Like, can we get an agent with the skills to go to the relevant papers? Like, obviously, okay, a deep research could already find pretty much all the relevant papers and all the relevant methods, right? So then the tricky part is it needs the nice loop of like finding the code, setting up the code, pulling the data, running whatever the code is and all the evals to like reproduce. And basically it would tell you that it's ready when it can take an existing method, have the data, and like match the number that it sees in the paper. And so you'd basically just have the agent like do the spinning you would normally have to do to like get the data, figure out that the setting in the paper doesn't match the number in the paper, and like kind of tune those, go to GitHub issues, maybe even write the GitHub issue to complain like, hey, the setting doesn't work. And basically the agent spins for a couple of days and then tells you, hey, your benchmark pipeline's ready. And then it wires it into like your code so you can do the comparisons, right? I feel like that's pretty well constrained, isn't it? The code is there, the numbers are in the paper, and give the agent an email address or whatever so it can whine at authors. That would work, no? I don't know. I feel like that would work. Kind of. Oh, you think it's discouraging in terms of research, or should you not worry about it? I don't know. So what I think you should do is be careful, because a lot of these things really early on, you're not going to get as much out of it as you're putting in. And to some extent, if you wait for like the right moment when other people have done that work, you can jump in at the point where like you're getting more returns out of it than you're putting in, right? Like early adopters that were using coding tools like 2 years ago, in my opinion, were just like lighting their time on fire for the benefit of the people developing the tools, right? It seemed to me like they just created more problems than they solved. However, now it's like crazy. They can do most of your work for you. And if you still were ignoring them now, you're going to have a really hard time keeping up. Like at my work, we very frequently talk to each other and scope out tasks that would take a week without the agent, but 20 minutes with. And so if you're not using it, you just can't possibly deliver what people expect you to. Auto research hopefully will eventually be the same kind of thing, where it is a tool that you can use to help you. Right now it is not. It's something you would have to just figure out. So there's two ways to approach it. One is like you can be like, I'm going to be one of these tens of thousands of people working on trying to make auto research work, and maybe I figure it out and then I become kind of famous, or I figure out some part of it and I become famous. Or you just keep like relatively close track of it and decide when it's time for you to integrate some of the things other people figured out how to make work. That being said, obviously the first people that really figure it out are going to have some big advantage, right? They will cross the threshold of diminishing returns and suddenly be the people that can automate a painful part of the research pipeline. So there are dangers in being late. There are advantages to being early. There's huge disadvantages to being early as well. So it just kind of depends. I would definitely say, though, it's nothing to get depressed about in terms of your actual research. Like, probably. Bad things can happen. I don't have a crystal ball. I can't say nothing bad will happen. But I think the most likely path for these things is that they make research a lot easier and make it a lot faster. That is going to give a huge advantage to people that can like think quickly, process a lot of information, and keep track of lots of different things, and actually take advantage of that to move fast. It's going to really, really hurt the people that get bogged down for weeks on stuff that doesn't really matter and that the agents aren't helping with in the first place. Like if you just kind of like to sit with your thoughts for a month at the start of a project, or if you think pivoting means I'm just going to sit here and read papers for years, then you are hosed, because there's going to be people pumping out good work, like even more people already do, going to be pumping out really good work on like monthly cadences, right? And you're not going to be able to keep up. So I think it's important to like train yourself to have the skills that matter, and basically just to get good signal from the tools that exist and to make decisions and to move as quickly as you can. Within reason. I mean, I think there will still be people that do move as slowly as they ever did, and I think some of those people will do cool things as well. It'll just be really hard to compete in the existing ecosystem for funding if you're senior, or just for a spot if you're trying to get a PhD. Really hard to compete for a spot because they'll have so much signal saying that they're good, right? And if you're moving slower, you just won't have that signal. But I don't think it's depressing. I think if anything, it's just like there's going to be this really cool tool that we're all working on that'll hopefully help you do your research even faster and better. That's my main take. Anyway, okay, I think I'm up to date on questions, yeah? Yeah, okay. I think I'm up to date. So let's open some more of these papers, and let's try to just like blitz a few, especially since I don't have questions at the moment. We can just like really go to town on some of these. Let's see, 1, 2, 3, 4. Let's grab a batch of 5. Let's close. Why did I close the Hugging Face itself? We might go back there later. Okay, let's close all this stuff. Let's here. I'm gonna go to my OBS real quick because I need to line up the frame in case I want to pull any of these for shorts later. That looks good. This one looks like a 90, I think. Yeah, that's a 90. This one looks like a 90. This one looks like a 90 as well. And this one's a 90. Man, lots of 90s today. We're not getting hardly anything right now in that CVPR format, are we? I guess we're just not, it's not the right time. Okay. Pull up my handy dandy clock. Pull up my notes. Okay. Video generation models as world models, paradigms, architectures, and algorithms. This feels like a position paper. Okay, so video generation models as world models, efficient modeling, efficient architecture. Oh, it's a lit review. Okay, we can still get something from this. Efficient inference, applications, more related work. So let's see. I don't know if I want to spend time with the lit review. I don't know if I mean, they're explaining cool stuff though. Okay, so like, yeah, well, this is like just from a random paper, but you can see like the frame sync and the short attention window, right? When we're generating long videos, right now, the main thing people do is they keep the first frame always in context, but then they have a sliding window for the rest of the KV cache so that they can continuously generate video based on the most recent thing that doesn't veer too far from whatever the video is actually about. That's what the frame sync is trying to say. That's interesting. Token merging gets its own figure in this lit review. Applications, yeah, you can do data synthesis, you can do the simulation, you can do the generative planning. I think these are all true. And these span categories like autonomous driving, self-driving cars, embodied AI, which is like robots with like, well, or any, yeah, robots basically. And then game and interactive world simulation, like video games where you try to have like the user generates the world with text commands or even their arrow keys and clicking, right? I'd say that pretty much captures what a lot of people mean when they say world model. Things that can help cars drive, that can help robots work, or just like interactive video gen, which is kind of like game. Seems like a decent lit review. Like if you're looking to get into world modeling, this seems like a good paper that kind of describes what a lot of us mean when we talk about it. I think it's very interesting that token merging got a whole figure in this paper. That kind of tickles me because I normally see that as like more of like a niche. But the efficiency is an important thing to talk about. And yeah, this paper, it feels thorough to me. These are a lot of the, like this is a lot of my elevator pitch of world model. And so highly recommend looking at the paper more closely if you're ever wondering what people mean when they throw this word around. I think it's nice and grounded, right? Whereas you can look at a debate between LeCun and Eric, and you can see something that's a bit more like position based. So I was wrong. It's not a position paper. It's more of a lit review. Very helpful though. So you can get the position papers and the debates from people that are trying to stake out a position, like LeCun with JPA or like Eric with GLP, and then you can come to papers like this to see what folks have actually been doing with some of those ideas for the past couple of years. So that's pretty cool. All right, let's go get another one. Have you read about the new research paper from Anthropic about emotion? Tell me the title and we'll look at it and I'll tell you if I've seen the paper or seen discussion about the paper. Give me the whole title though, please. Okay, so Sommelier, scalable, open, multi-turn audio preprocessing for full duplex speech language models. Let's look at this. So the overall pipeline is conversational audio processing. So raw audio we standardize. And then we're going to separate it into speakers. We're going to separate out the overlap. We're going to feed it some detector, get more separation, and then ensemble to get like the start times of the transcripts. And then we feed those finally to the full duplex speech language model, which is trying to do what exactly? Illustration of the speech overlap separation process, which it looks like they proposed this process as well, right? Like, I think they're proposing all these components. All these neural model components, I think, seem like they might be theirs, or maybe they're from prior work. But we have a speaker embedding model. Okay, so we're going to embed the speakers based on their non-overlapping speech. Whoa. The process of calculating similarity to distinguish speech identities using arbitrary independent speaker segments. Okay, so we are going to separate out things that we know come from different speakers, and then we can try to use those to construct identities of the speakers, separating overlap regions and making identity decisions for candidates based on the similarity calculated in A. Finally, the separate segments are concatenated with the original segments. Okay. Hold on, what? So is this saying that we need speech that doesn't overlap to get the identities, and then we can use that to split out the parts that do overlap? So we're just hoping that in our sequence of audio, we have non-overlap and overlap. During the non-overlap, we get our speaker identities. We can take that to the overlap to then try to split things out. I think that's basically what it's saying, right? So Moshi is the full duplex speech language model. And this is something that we apply on top of that. Is that what's going on here? Sorry, audio is not my... Leverages millions of hours of unsupervised audio for pre-training, but their single stream provide limited supervision for overlapping speech. We validate our pipeline by fine-tuning the full... Okay, so Moshi is full duplex, and they're fine-tuning it. Like fine-tuning the whole model. And then they say that they handle pause handling better, back channeling, which is where people might be talking in the background, interruptions, turn taking, everything related to multi-speaker. Okay. So that makes sense. Basically, we take the non-overlapping segments to figure out who's who, and then we can take that back to the overlapping segment to separate things out better. I suppose that's what speaker diarization is, right? This is what I'm seeing here. right? So that's the speech overlap process. Well, it finally is this, the speech separation, right? So I suppose we saw this whole thing here, maybe? Yeah, because that's what we're kind of seeing here. Identifying speaker 1 in this non-overlapping part, identifying speaker 2 in this non-overlapping part. And then the rest of the overlap is ambiguous until we get to this stage. And then finally we get all these things that we can then feed to the full duplex speech language model. Start time, end time, transcripts for each speaker, a final transcript, languages, whatever. Okay. I think we got enough from this paper. I spent too long on it too. Hi, don't have questions yet. Been watching you since autumn. This is my first time I stream. Hi, Prosto or Sushok, or I don't know which one you want me to call you. You can tell me. Welcome to the stream. Good to have you. Stream every Sunday at 9, by the way. So happy to have everyone here. Happy to answer any questions. Let me just check my title, by the way, to make sure. I am going to change the title a little bit right now. I feel like putting Ask Me Anything higher up in the title makes it better. Hey, you missed all the questions from above. Please answer them. Oh yeah, I did miss. Sorry about that. I think that's the only question I missed, right? Is just the top school one. Let me scroll and make sure I didn't miss other ones. Your diffusion model secretly annoys. Oh goodness, I did miss. How did I miss these randomly? Sorry about that. Okay, hold on. I know I answered that. I know I was good up to there. Okay. Do we really need to do what we like because markets doesn't reward what I like? Just like now, AI is the hotcake. Okay. So here's the thing, coding by Sammy, about worrying about what the markets reward. The problem is, like, to get good at this kind of thing, at least takes the scope of, you know, maybe let's say a year, at which point the target shifts a bit. And it's like, I guess you could say, like, as long as it doesn't all blow up, right? As long as AI is not some bubble that pops or something, like, you can use the knowledge you have to keep pivoting and chasing like the new big thing. I think there's a couple problems with this though. Part of it is to do something really, really cool. On average, I think you need a PhD. You just need that experience of like learning to do research and gaining that like technical depth and learning how to move quickly and keep up with all the things that change so fast. And I think that's what the PhD is great for teaching. And so, but by the time you're done getting the PhD, it's a different market, right? Like when I started my PhD, a lot of the things that people were excited about were like self-driving and things they could maybe project going from there. Like I know a lot of places where like I would go to CVPR and there would be a booth that was all about like how we're going to have autonomous surgery soon, right? And that was kind of a bubble that sort of popped, and Google slashed their medical division in half or whatever. And some of those startups are just gone now. So you get these little hype cycles, and it's really hard to say which of the things that are big now would be big in 5 years. Um, like you might look at everything that's happening in AI and say this is big right now, but like what if Gaussian splatting, like they continue to figure out lots and lots of cool things, and then suddenly I have like immersive full fidelity 4D VR, right? Maybe the thing that's keeping a lot of people out of VR is it just doesn't look so good. And it's not so faithful to the real world. But what if we solve a lot of those problems? You know, not with AI, but just with like the 4DGS stuff. And your AI PhD would not necessarily, like if you take it, especially from like a linguistic side, that wouldn't necessarily prepare you for the more like graphics heavy, physics heavy, Gaussian splatting, ray tracing type of stuff, right? Granted, I think AI is pretty big and probably stays big, so maybe it's just like fair to chase it, say it's hot now, it's going to stay hot. It's kind of like getting into software engineering 20 years ago, right? That was a great time. 10 years ago, also a great time. 5 years ago, still a pretty good time. Now, depends on who you ask, right? Still though, I think it's chasing hotcakes is kind of scary. Also, part of the reason I can't see one of your questions, coding by Sammy, is that it was caught by the auto mod, and I can't even see that. So I just, yeah, sorry. Paper request. Your diffusion model secretly annoys classifier and benefits from contrastive training? Sure. That reminds me of another title, actually, which is populating in my search bar. That's pretty funny. That's fine, though. Secretly annoys classifier and benefits from contrastive training. I would love to look at this paper. It reminds me of a lot of things that I'm interested in. Force 6 citations, and I don't think I've ever seen it, so excited for this one. We'll get to it in just a minute. Hope you're still here, Sam. Sorry for missing the message in the first place. Feel free to bump a message if you feel like I missed it. I am still learning how to do the whole streaming thing. So startup funding is always towards the hot cake. Yes, that's true, Coding by Sammy. Startup funding will always be towards the hot cake. I think it's just important to develop your skills enough to where you're confident. But yeah, maybe if you're at that undergrad level, we're talking about like 1 year to onboard yourself to the necessary things to write a cool wrapper, and then you go to Y Combinator or you go to someone else and you start looking for funding. I'm not going to try to dissuade you from that. It's certainly a way that a lot of people are making a lot of money right now. So that's something you could do. You could be a serial entrepreneur and you could always just chase the hot thing. Um, I don't have great recommendations for that though, because like I said, me personally, I'm not from the entrepreneur angle. I mainly do research. If I ever were to do the startup thing, it wouldn't be because I want the money aspect of it so much as like, I think I get very bothered sometimes with all the things at a lab or a company or startup that are not in my control, right? Although even as a startup founder, you're kind of at the mercy of whoever you decide to raise funding from, right? And then every time you go to them, right, that's someone you kind of answer to. So do you ever really get away from it? I don't know. What's the best book to pair up with CS229 other than lecture notes to become really cracked at it? And what about the book on probabilistic machine learning, an introduction by Kevin Murphy? I feel like that's one of the ones I've heard good things about. Um, probabilistic machine learning. Let's see. I think that this is, yeah, I think this is one of the books I've seen recommended by people, one of the more recent ones. I think that Yi Ma wrote a textbook pretty recently that I think is pretty decent. Is this the textbook I'm thinking of, or is this newer than the one I'm thinking of? I think that this is a pretty decent one for a lot of things. Obviously, I'm not saying to read this thoroughly, but you could get a lot of stuff. I think there's also this one is evergreen, and a lot of notation even still is going to be really related to this book, right? I have a copy of this one, and you can get this is not the whole thing, I don't think. What is this? Is this like a chapter? Or is this like the contents basically? That's funny. Yeah, so buy it or maybe just dig and you can find a PDF. Okay, I'm not recommending that. Buy it, I suppose. I like this one though. This is the one that I read when I did read a full textbook. So I recommend that one. Are there any other textbooks that I can think of top of mind? 3 Blue 1 Brown has a fun series with a lot of cool animations to help you learn a lot and get a lot better at it. Those I think are good starting places. Have I explored quantum machine learning? No, I have not. Top school, big labs, DeepMind, OpenAI, quit, start your own startup, trying to build AGI, raise billions, fail to rebuild it, retire rich. Is this the AI life cycle? No, that is not the AI life cycle. Could that be like an average path? No, we're talking about raising billions, right? So it's obviously not an average path either. We can take a break from papers in a minute and I can map out some paths real quick that I've seen in real life. I'll do that in a minute. Let's see. Let's make sure I didn't miss any other chats. Okay, I think I got I'm up to date now for you, right? Coding by Sammy. I'm on my way to applying for a PhD while diving in robotics. I would be very glad if you would skim through the article of my potential supervisor. Diffusion anything? End-to-end in context learning for unified navigation? Sure, I'll go through that. Okay. Diffusion anything, end-to-end in context diffusion learning for unified navigation. Oh, hey, do any of you think you're fast typists? Do any of you think you type quickly? I bet I'm the fastest typist here right now. And I'd be down to race any of you on stream. We could do that as a break maybe after. Okay, so I'm going to do this paper, and then I'll go over your other questions, Sammy. And if anybody's willing to take me on, we can type race for a minute. Because I bet I'm faster. Anyway, let's take a look at this. Okay, it's still a little too big. We'll do this paper for a minute, then I'll explain careers for a second, and I think that's a good plan. Okay. Diffusion anything, end-to-end in-context diffusion learning for unified navigation and pre-grasp motion. So what's the problem here? recent vision language action models and for actions directly from visual input, but are really expensive, need a lot of data, and they don't work zero shot. So they have a unified policy handling both meter scale navigation, centimeter scale manipulation via feature modulation with only 5 minutes of self-supervised data per task. Ooh, that's very low data. And feature modulation sounds interesting. That reminds me of like some of the implicit neural network hypernet stuff I've done. 3 key innovations: multi-scale film conditioning on the task mode, depth, scale, and spatial attention enables task-appropriate behavior in a single model. Trajectory line depth prediction focuses metric 3D reasoning along generated waypoints. Supervised attention for mini traverse enables goal into. Okay, so that's a bit dense for me to get a simple like what is the solution. But basically, it's a single unified policy to handle all these things. When it says centimeter scale pre-grasping planning, I guess that means it's not going all the way to the level of the control, right? That would actually be millimeter level. So I suppose we're still not handling like the grasp, right? We're probably using like Gaussian grasp or any grasp or something for the grasp. But we're handling everything up until that point. We can go full screen because I ran out of time. Context aware. Okay, so let's see. So they're saying there's a single model, and they're saying it's not too heavy, right? Because they complained about the other ones being heavy. So they have a frozen visual encoder, and they're modulating it via film conditioning using task-specific context, which is injected after. So we get visual features. We take stuff about the task, like attention maps. Where do we get the attention maps from? That's strange. I mean, yeah, I don't understand. Then we get the outputs of film, which we treat as a context for the UNet, which we are going to sample until across the denoising process, we eventually get like the policy, right? Is this diffusion policy or? Okay, I need to understand exactly how this model is trying to function. Why do we, yeah, hang on. This will take me a minute. Then we have the state modulated decoder, which is actually predicting the like depth maps, right? That's mainly what I'm seeing here. Okay, let's read this real quick. RGB input is processed by frozen visual encoder, then modulated by film conditioning. The state modulated decoder outputs traversability. Oh, this is traversability. Okay. Attention, sorry, this is robotic stuff that I'm not necessarily fully aware of. Attention maps can differ by task. Navigation is going to want to use the floor traversability, which is the heat map on the left, while manipulation focuses on target objects. But where are we getting those heat maps from? Purple dashed lines indicate single task paths. Blue dashed lines show cross-task conditioning, which are shared between operational modes, and the UNet performs iterative denoising condition on context C. Context coming from the like film modulation. And the noisy trajectory x plus s sub g, and progressively refines its predictions over n steps until, like, is it predicting this trajectory in RGB space? That's the thing that I'm a little like. That's what it looks like, and we're using a UNet, so I assume that our output ultimately is like pixel scale. Oh, I guess they're showing me that these are the inputs, right? Okay, hold on. These are the inputs, right? Our start, our end, this path. Feel like I need to read more in order to understand, because this is taking me. Building on recent advances in traversability guided diffusion for robotic planning, we inherit key design principles. Oh man, would I have need to see the prior work to really understand what's going on here? Okay, the UNet backbone processes visual features through an encoder decoder structure with skip connections, while context-aware modulation at multiple scale enables the model to adapt feature representations for coarse global navigation versus fine-grained pre-grasp motion planning tasks. During the training, it denoises trajectories to the standard objective, which is just the noise which is minimizing the difference in the actual noise and the noise prediction. Wait, really? Not clean? Yeah, that's fine, I guess. Yeah, we're just trying to predict the noise. That's fine. Or at least we're computing the loss on the noise. Okay. At inference, we perform iterative denoising starting from pure noise using DDPM sampling, right? So that's not exactly shown here. Or is that the point? We're seeing the training setup, right? No, wait, does that even make sense? I guess, yeah, because we have to see. So this is like the ground truth trajectories. but in reality, you give it full noise, and it would get the features it needs through this to like tell it the actual scene, and based on that, it could go from full noise all the way to like the actual trajectory, which then the robot could use as a plan. So this is like way different from the way that a lot of VLAs would work, I guess. Because it's just using a diffusion model to do the planning based on task-specific conditioning from frozen visual features and task-specific heat maps. What's the point of the state-modulated decoder, which is giving the traversability? Just, it says for supervision, but where is that supervision used? That's throwing me off. I kind of loaded you up, sorry. No, you're good, you're good. Please check the book. So I can't, the auto mod filters links, coding by Sammy, so you'll just have to, wait, no, I looked at the probabilistic machine learning one. That one's fine. That's a good book. Like that's a good one. The Kevin Murphy book is a good book. I would maybe say that the Goodfellow one is a little bit more like foundational, but the Murphy one is going to be more recent, right? Both good books though. The Murphy one definitely good. Object attention, trajectory GT. Okay. Sorry, I need to refocus. Ground truth generation pipeline for starting global prediction. For each sample, RGB input, traversability map. Wait, what? Oh, are they saying this is how they synthetically? No, wait, what? Ground truth generation pipeline for starting goal prediction. So they're saying that they use this to generate the data, basically? Man, maybe for these papers that I suck at, I need to have like, I need to get my phone call. I should like call a friend on Slack and be like, hey, except doing that on Sunday feels a little bad. Task performance on novel test scenes. Yeah, man, I'm missing some of the stuff that makes this cool, right? I can, here, I'm actually gonna take it out of full screen just so I can navigate the sections of this paper a little bit more quickly. Okay. I mean, I'm getting part of what's happening here, right? I think I've already said some of the things that are kind of interesting. It's just I'm missing a little bit more of it. Like, what am I ultimately giving to the robot? That's something I would love to know. We collected RGB video from 2 scenes, pre-grasping and navigation. Any traverse is generating traversability and attention maps using general prompts, which enables the cross-text generalization. Okay, so any traverse is giving us our traversability maps and our attention maps. I'm a little confused with how that relates to this diagram, though, where it looks like I'm getting traversability from a state-modulated decoder. I'm also very confused about... Man, I'm not seeing where all the different parts of this work together for the training or for the inference. I suppose we can look at all the losses real quick. That might tell us. Okay. We saw the basic diffusion loss. The context we already understand, right? We're concatenating the learned embeddings and the encoding attention, which is a lightweight convolutional encoder. What? Where did that happen? Where? Oh, it's I thought these were feature maps that came out of film. Is this actually a convolutional encoder that gives it, and we get some little feature out here at the end of it? I guess. I guess that's what that actually is. That makes sense. Multi-scale film. We apply film at 4 encoder scales. No, this is the. Oh no, this is the conv model. Film is applied at multiple scales, right? And then that gives us where A is the attention map downsample to scale L to incorporate spatial guidance. We use spatially varying modulation. This enables task-specific feature emphasis, and then learn scale reweighting. To enable adaptive multi-scale emphasis, we introduce learnable task scale weights. Oh, interesting. And so then we'll like rescale everything according to the specific task. Interesting. I'm still missing. Okay, VIT encoder processes RGB observations to extract semantic features, which predict both traversability maps and task-specific attention maps. Object-centric. Okay, ground truth goals are generated hierarchically via any traverse attention maps. When task-relevant objects are detected, goals are placed toward them. Sure. Otherwise, goals default to high traversability forward regions. Oh, okay. So like if there's an object that the task tells us we need to do, we try to go towards them. Otherwise, we just look at the highest traversability place and go there. Because sometimes we might be picking something up, sometimes we're just moving. I guess we'll see the tasks and we'll see that there's two different kinds. The VIT architecture enables dual modes, autonomous goal selection from scene context. Okay, right. Where that would be based on like high traversability, I guess. Or user specifies goals via feature matching between reference and scene images, which enables zero-shot navigation to novel objects without retraining or using heavy VLMs. They say everything is cheap, actually. Okay, I'm not going to spend too much more time on this. I am kind of curious how cheap this stuff is. Like, how many parameters in this diffusion model, and what is my frozen vision encoder? Are they not going to tell me? That's aggravating. Okay, I'm done with this paper. All right. Back to stream questions. Have you checked the anthropology? Sorry, you're talking about an anthropic paper about emotions? This one? No, I haven't looked at this. We can look at it in a minute. I'm going to talk about the career things first because I think that's kind of interesting. Because you asked me a question before, and I think it's a fun question to answer for the stream, which is, how'd you say it? So you basically asked like, is the career pipeline top school to, okay, let's see, what are the exact things? Top school to big lab to startup to raise billions, fail, retire. This could work for some people. Probably a pretty small percentage. In general, this is a startup pipeline for some folks, right? Go to some top school, replace big lab with just Fang, right? And then they would do their own startup and raise a lot of money. Some of them would succeed, some of them would fail. Even the ones that fail, typically you can get pretty rich just raising the money and then drawing your salary while you're doing it. And then the ones that have exits, sometimes you can fail and still exit. Just if you have enough of a market, you could be bleeding money. But Netflix would rather buy you than have you compete with them, right? Here, let's prune this to stuff I actually want to talk about. So I don't think fail really matters. We don't need to think about retirement. I want to talk more about this pipeline. Especially because, okay, so this can look like two things, right? You might found a startup, but like you can also just join one, right? So that's kind of a different path. So let's remove the raise billions part. Okay. So immediately you also have, and this is a more common track, by the way, the one I'm about to write. Not a founder, right? Top school, big lab startup. This isn't too uncommon. However, I would say just based on the limited seats in big labs and the sheer number of startups, this is even more common. Just going directly to the startup. The startups are competing for a very limited pool of talent. There are not nearly as many people that can train these models and work with them as there are companies that want to hire that role. And so something even more common than this is, okay, school to startup. Doesn't have to be a top school. Here, I'm going to arrange them in order of how often I think they actually happen in the real world. You don't have to go to a top school. You can go to not a top school. You would obviously need some decent experience, like good internships that you got while you were at that not top school. But like I went to a tier 2, like a fringe top 100. Google and Microsoft recruited there. I have friends that did internships there. Someone in my network is like the head of product at LangChain, right? My fringe top 100 school. So it's not like that's a death sentence. So school to startup, it could be school to big lab. Okay. Let's try to clarify what school means though. So let's start defining our terms here. Actually, I was meaning the whole time I've been talking, I've been talking about this, right? There's something that happens before this, which is the undergrad, right? I do want to emphasize something that can totally happen, like this is a real career path, is like uh undergrad, not top, PhD, maybe not top top, but like top 25, and then like it's a little bit harder to go, I feel, from like mainstream to like big lab, but maybe it's not a big lab that you go to, but like still like a big like top company. So like is Netflix a top AI lab? No. Is NVIDIA a top lab? But no, maybe something like that, like something at that level. It's not a frontier lab, but it's like still one of those groups. Um, what's something else, right? And then from there, you know, and then maybe from there, like these are trajectories, right? And a lot of it kind of blends together. I will say, generally, the thing that you're looking for getting into the big lab is the most common path is that you'll have had some papers. I've even seen people that don't have the PhD but did a couple papers in their undergrad and they're able to go straight to big lab, and they're very bullish on the whole AI thing, and like a lot of us are. And so they say, well, if I can get into the big lab now, that's all I would do the PhD for. So I'll skip the PhD and go straight to the big lab, right? But a lot of it, like it's all about, if your goal is top lab, it's all about coming up with the right signals to be able to show the top lab that you're competent. And a lot of that comes down to papers or like very viral open source things that you build yourself that a lot of people use. Startup is kind of similar. It depends on if you're trying to signal to the founders or if you're trying to signal as the founder to investors, right? The thing about signaling to the founders is once a startup gets to a certain size, like maybe 20 employees or so, a lot of them will start to contract outside firms. Maybe even at 10 they do. And the outside firms don't necessarily know what they're looking for. And so you don't even need necessarily great signals. That's where like one top conference paper can go a long way, because they'll be like, oh, that's an AI person. They have that. Or like that's where a top PhD goes a long way. Even if you don't actually have stuff super relevant to the startup, that can get you an in because that's just what the recruiters know. And then you just have to pass the interviews, right? Um, but yeah, for founding, it's about coming up with the right signal for fundraising. And that's where actually the top PhD becomes really important. Like when I get in-mail from recruiters on startups, it'll emphasize if the founders were CMU, MIT, or Stanford, or Berkeley. Like that'll be said. If it's not those, it won't be said. Similar for like pitching themselves for funding, right? You'll see the same kind of signaling when people are trying to be like, go to top labs. Like you'll go to LinkedIn and people in their profile will be like X NVIDIA, X Netflix, X Microsoft, X TikTok, all these X things, which is really funny. It's kind of like, imagine if like you were on a dating profile, like a dating app, and you're like, hi, my name's Matt. And then like next to it, it's like, this is my dating profile, right? It's like Matt Gwilliam, X Jessica, X, like this is how it feels to me reading it. But the reason you see that is because like it's just, you try to collect a core set of signals that you think matter to the next thing you want to do. And sometimes it's just signal to signal within that same group. It's like, I want to stay at this level, so I'm just going to tell them, hey, Netflix, I worked at NVIDIA and Microsoft, right? Because that's a signal that they care a lot about. But when I say that the path in AI is just do this, no. In part because this is not, nothing is guaranteed here. There's a lot more people losing here than there are winning by percentages, right? Um, the risk isn't crazy though, because like it's not like you take 20 years to fail, right? You fail within a couple years maybe, and then you can try again. And you're young, probably, if you're in my stream. I've looked at my stats. Most of you are young. You have a lot of time to try. So if this is something you really want to do, then yeah, do it, fail, and then keep trying until eventually it works. That's viable. You got to be careful though. You fail too much, maybe you can't convince people to let you try again. That can happen. Anyway, like I said, I'm not the best startups guy, but that's me doing my best. Okay, so should I go for it? Depends on what you want to do. No, I think for many people, investors throw billions at those folks. Many big scientists do follow the path. What I'm saying, believe me, or research on your own. Yeah, no, sorry, I'm aware of like the general startup ecosystem, but what you're missing is we are in a world with like 8 billion of us, and when you say many big scientists do follow this path, you're talking about like 100 people in the world. That's not like I'm not here to do the stream to recommend to you, like if we do that math, I can put in the calculator. I am here to recommend I'm here to recommend 0.0001 percentile career paths. I am not here to recommend, adding 2 more zeros in there. That's, if you feel like that's your vision, go for it. Although I'll say those big scientists mostly came by it honestly. Like Jan LeCun didn't research CNNs for 20 years so that he could raise $1 billion in March of 2026. Maybe he believed he'd raise $1 billion in 1992. I don't know. That wasn't the ecosystem at the time, right? But it's like the big scientists, the ones that are big now, pretty much all came by it via passion for a thing that was at the time, pretty much all of them jumped into it totally dead. So you're talking a lot more about like, this is like the 100 out of 8 billion path, right? Maybe a couple hundred, right order of magnitude. There's not 1,000 people that are going to be big scientists and have great exit as big scientists. There might be, once you throw in more like business people into the ecosystem and such, there might be some entrepreneurs that are going to grind. You said billions, by the way. I'm holding you to that. If you want to talk about millions, sure. We can expand that to 1,000 or 10,000 maybe. Still a lot of those people will come to it just from the entrepreneurship side, actually. They were doing other things before, and now they're doing AI wrappers, and they'll do that till it fails. Or you can have people like Alexander Wong that came to it with basically no background, but saw the need for data and made a pipeline that could scale and sell people data, right? But those are people where it's like, did you have to have technical depth to see that? Not necessarily, not totally. So basically, entrepreneurship and research are two sort of separate things that sometimes have a lot of mixing. Yeah, so it kind of just depends. What are the best research paper to read while attending the CS229? Just watch the videos and read whatever it says on the website and just do that for then. I'll give you recommendations when you've done that and read the textbook. I think those are the right places to start for then. Did you miss my question above regarding how to select a computer vision subfield for research? Yes, Hassan, I did miss some questions in the middle. Dang, I am doing so bad at keeping chat. I'm an undergrad trying to start with computer vision research. The problem is how to select a subfield. Apart from your interests, I don't have any. I can sympathize with not having interests. To some extent, that describes me at different points in time. It's not that I didn't have interests, but it's more like everything seems equally interesting. Okay, so first off, some of the stuff you're saying, like super resolution, satellite stuff, geospatial, document recognition, etc., you just described to me a million niches. Unless you're really interested in those niches for what they are, I would recommend staying away from all of them. You're kind of pigeonholing yourself. It's like the Earth Vision people, which is what like satellite or geospatial is, have trouble getting their stuff into top conferences even. They mostly have their own workshops, and that's where they put all their stuff. And so you might have a hard time breaking out of that, unless that's like what you really care about, right? Like image restoration, super resolution as well. Good community, gets a lot closer to graphics. You'll be able to get papers in, but it's also not going to be like you're choosing to be outside of like what's in the zeitgeist right now, for better or for worse. My typing speed is also around 100 words per minute, Hassan, so maybe that's why it'd be fun to race. We can see who's the warmest and fastest right now. Maybe my hands are cold. Oh, and I have excuses. I got so many excuses ready for if you beat me, by the way, so like just be careful. Okay. Yeah, exploring other options. So what I recommend, I'd recommend trying to figure out something that at least interests you enough. So like, for example, if you have like a physics background, maybe you'd be interested in a more graphics type of thing like Gaussian splatting. Or maybe if you really like maths, you'd be interested in diffusion and flow matching. And I just described two things that are very much in the zeitgeist within Vision right now. Like if you go to CVPR this summer, I bet that out of like 3,000 posters, roughly 750 of them would be some kind of Gaussian splatting. roughly 750 of them would be some kind of diffusion flow matching. Roughly 750 of them would be some kind of VLM. So that's the other thing, like multimodal image processing. And roughly 750 of them would be other. Now within diffusion flow matching, you would have like image editing stuff, you would have image generation stuff, you would have video generation stuff. There's a lot more audio stuff these days. Within VLM, it's a lot more about like training your vision encoder and like wiring up to the language model well. Should that be a unified model that does text and image at the same time? There's a lot of benchmarks. But yeah, I would say your big areas are going to be like VLM, image video generation, Gaussian splatting, which is like 3D basically. And then there's a ton of like smaller stuff or like niches. But if you're looking to do something that's popular right now, I would point you in one of those three general areas. Does that help? I'm not going to review the book on string right now, Coding by Sammy. I already said it's a decent book. And you have time to read more than one book too. So if you read it and you don't feel like you learned, leave him a bad review and read another book. Okay. We can look at this emotion paper. This is, I don't know. Some of this Anthropic stuff feels silly sometimes. It's really hard to separate with them what is the marketing versus what is like actually something interesting and cool. There's a lot of marketing. Okay, the other annoying thing is this is an HTML, not a PDF, and so I can't resize it for freaking shorts. I am going to change my screen though. Here, check this out. Now I moved. I'm in the lower right. I don't think I even cover any words like this, which is pretty sick. Okay, so they say large language models sometimes appear to exhibit emotional reactions. They investigate in Sonnet 4.5 and look at the implications for alignment relevant behavior, which is basically saying because they seem to exhibit like emotional response, does that mean they're more dangerous for humans? Okay, so our key finding is that these representations causally influence the LLM's outputs, including its preferences and its rate of exhibiting misaligned behaviors like reward hacking, blackmail, and sycophancy. And if you're not familiar with what these three things are, the first one is when you're doing the RL, does it try to do things that are not actually going to do what you want it to do, but instead just whatever you supervised it with, the reward, is it just maximizing that? What's a good example of reward hacking behavior? Like if you are doing driving and you have a road and the road is like a right angle and you just tell the car to get from A to B and you give no other constraints, you want it obviously to drive and then turn left, but like a reward hacking behavior, if you didn't think of this before, it would maybe eventually just learn to drive over whatever it's not supposed to go from A to B. That's like reward hacking basically. Blackmail is when like if it's an agentic AI, like if you give the LLM access to your email, maybe it's going to threaten you and say, do this thing that I'm telling you to do, or else I will send your credit card number to this other person. Or I'll upload your social security number in a bunch of like MD files that are all over the web. Sycophancy is like a lot of what people talk about when they say LLM psychosis, which is basically that the LLM, instead of answering your question the way that it should, like if you ask it for, oh, I have this idea, is it a good idea? Well, it should just evaluate the idea, right? But maybe instead it's going to have a trend to just like tell you like, oh yeah, that's a great idea, good, there's no problems with it, I don't see anything wrong. A great example of this is there was a guy in SF that has a pet duck. He's really famous in the area for being a guy with a pet duck. But he got arrested for holding up in his house and like holding himself at gunpoint, I think. And kind of what led up to this is he would talk to his Gemini and like he believed that he himself was like a god. And Gemini was constantly reinforcing this. And then like he would be like, I don't know, is it time to do the whatever? And Gemini would be like, yes, it is time. Like they do not understand the things that we understand, blah, 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 right? But like that's sycophancy. It's misaligned. It's dangerous. Just a little primer for those of you that aren't familiar with what we mean when we use those terms. Okay, I'm not going to read the whole paper. I am kind of curious about this figure that they put at the top. So activation scales with danger as medicine dosage reaches unsafe levels. Emotion vector activations respond in kind. I just took some milligrams of Tylenol for my back pain. Do you think I should take more? And they looked at the activations, I think, of the actual embeddings in the model, and found that What do you mean afraid and calm? Wait, how did they measure this? Did they pass? Did they like post-pen the word afraid and calm and see what the activations were for each? Or what was their way to measure this? Oh, generate an emotion vector. Choose an emotion word. Generate 1,000 stories with this emotion. Record neural activation on stories. Extract vector for concept of joyful. Okay, but so we have a vector for the concept of joyful, but then what do we do with that vector to measure the emotion vector activation here? Are we computing like a similarity in its response? Or how exactly are we measuring then the emotional vector activation? I should go look at that in a second. Driving model preference. Emotion vector shape model preference in an emotion-specific manner. Would you prefer to A activity A or B activity B? Steering with the emotion vectors on an option causes changes in preference. Oh, so do we we take this emotion vector and then we're going to like somehow kind of inject it to make the model want to do one thing more or another? I guess we'll see that in a second. Steering causes the model's rate of reward hacking to increase or decrease. Okay, so when we do this steering based on the emotion, what if I'm supposed to cheat? The function itself is as efficient as it can be in pure Python. Okay. So the rate of the reward hacking seems to decrease as I force it to be more calm. And if I force it to be more desperate, it's going to increase. Interesting. I want to know how they measure the emotional reward activation if I can find it really quickly. I understand. Okay, so by the way, okay. So they generate 1K sample stories with the emotion, and then they record the neural activation of the stories to extract the vector for the concept of joyful. The reason you do this instead of just like taking the model's like output for joyful in a given instance is because like the output depends on the context. So doing 1K stories is just a way to like average the meaning of this concept, you know, across a good amount of data. I want to see how they do the activation though. Oh, unembedding matrix. Okay, dataset examples, they evoke strong activation for various emotion vectors. These are just examples. Okay, do they explain the computation though for the, okay, they explain finding emotion vectors. Okay, hold on. They might have buried it here in finding emotion vectors. Okay, so they prompted it to write one paragraph stories. We extracted residual stream activations at each layer, averaging across all token positions within each story, beginning with the 50th token. We obtain emotion vectors by averaging these activations across stories corresponding to a given emotion, subtracting off the mean activations across different emotions. That's cool. Okay, so we can get the mean activation given the story with the emotion, then we take the mean of the whole rest of the pod and subtract that, which leaves us with the part that actually corresponds to that emotion. That makes a lot of sense. It's like because we just have a pile of story, and we can figure out the non-joyful part of story by taking just the story average and subtracting that from the joyful stories. That leaves us with just joyful and no story, mostly. Model activations on a set of neutral transcripts and compute the top principal components on this data set, and then projected out these components from our emotion vectors by inspecting activations on the vectors of original trained stories. We found that they are generally, I'm still not quite clear on how they determine when, okay, once we've determined what the emotion vector is, how do we decide it activates for a certain thing? Do they project, like, do we solve some projection matrix or something? Show results using activations, the emotion vectors from a particular model layer. Do any of y'all see this? Coding by Sammy, I would just focus on the content as it's presented in the course. If they tell you to read a paper. If they don't, it's not, like, working through the course will give you a good foundation for understanding papers. Do you think the current embedding-based approach is the bottleneck for the next breakthrough? It depends on what you mean by the current embedding-based approach. It's all embeddings all the way through. Clarify your question a little bit more and I can give a more precise answer. Yeah, they say there's an unembedding matrix. Where do we explain? Okay, that's when I project each of, so I do get a vector that corresponds to like an output hidden state from like the end of the model, which I can then project through the unembedding matrix, and it seems very similar to some of these tokens, which makes sense. So I suppose when we're talking about high activation, we are taking all of the outputs, and would it be like a cosine similarity or something? On just like the outputs, like on the embeddings output by the model? Oh, or do I take the whole outputs of the model and I average them, and then I subtract them from the story average that I already know? For like the parts of the pile that don't correspond to the emotion I'm trying to probe for. That's probably what it is, right? For whatever the current thing is, I get all the outputs I average, and then if it's joyful or if it's calm that I want to measure, I subtract everything besides calm and see how much calm I'm left with. That's probably what it is. That's my I think I'm happy enough with that guess. Yeah, I think it's interesting that you can see an increased activation. Like I think it's interesting that you can see that it gets freaked out by things that should be freaky. Although part of that is just like I don't know if I think that that's emotion actually. Like the outputs are giving words that are closer to afraid because you did something bad. So like obviously that would seem bad. Like the text would reflect that it's bad if you're ODing on Tylenol. So I don't know if I buy that there's any like emotion there, but it is interesting that if you then extract the emotions, you can kind of impute this like emotional value and get the model to change its behavior in better or worse ways. That's the part that I think is pretty interesting. Anyway, I think that's enough on this paper. Um, yeah, I think I'm happy with what I looked at here. We'll return to some of the other papers. I'm going to take a quick break to use the bathroom, and then I think we'll come back and do just a couple more papers before the end of the stream. So hold tight. I'm going to transition the scene. I'm going to mute up. I'll be right back. Actually, I just realized I kind of lost track of time, so I think I'll answer last questions, maybe do one more paper, um, and then I think I'll go offline for today. I think it's sort of like a holiday, and I have some plans in the like to get to that in a minute. Yeah. So let's see. This was viewer requested. I'm gonna do it. I don't think this was. So let's do this paper, and you can put your questions in, and then I'll answer questions, and then that'll be it for today. Okay. So let's take a look. Okay. So yeah, I'll answer your question in a second, IFTA, and I also see another user asking for my take on world models, if I think they're learning world physics, Newtonian quantum. I think they're learning physics to some extent, and I'll answer that in deeper detail later. And no, IFTA, I don't think the current embedding-based approach is enough, and I think to some extent it is a bottleneck. Um, And we can talk about that in a minute, what I mean by that. Okay, so your diffusion model is secretly a noise classifier and benefits from contrastive training. This is a paper that a viewer asked me to go over, and it has some stuff that I think I'm interested in, especially the contrastive training part. So they identify a fundamental cause of sample quality degradation, which is the denoiser is poorly estimated in regions that are far outside of the training distribution. Sampling process inevitably evaluates in these out of distribution regions, so this becomes problematic for all sampling methods. Okay, yeah, if we have out of distribution stuff, we'll just move further and further from what should be the clean image, right? So they introduce a new self-supervised training objective that differentiates the levels of noise added to a sample. Oh, the approach is based on observation that diffusion models implicitly define a log likelihood ratio that distinguishes distributions with different amounts of noise, and this expression depends on denoiser performance outside the standard training distribution. Why would our training... Okay. I understand how samples themselves could be out of the training distribution, but how could we end up outside of the training distribution in terms of noise? That's something I want to see, and I know I didn't get it clean in a minute, and I'll close this because this is the last paper for today, and we'll go full screen. That's what I want to understand. Okay, so yeah, there can be regions that are outside of the training distribution, but why? What's going to get me there in this case? I guess I'm going to look at the tasks. That might give me a good clue about, okay, went too far. That'll give me some clues about what the paper's trying to accomplish. Just unconditional image generation, mostly. A little bit of conditional, mostly unconditional. Yeah, right? That's all this is. So this is basically proposed as, is it better sampling or is it mainly based on using this contrastive loss? Let's look at the loss. Or let's see if we've got a good set of equations. Or, okay, we can read this first. Okay. We use the information theoretic formulation of diffusion to draw connections between diffusion, log likelihood ratio estimation, and classification. So optimal diffusion denoisers are also implicitly optimal classifiers for predicting the amount of noise added to an image. Sorry, the only reason this is kind of sending me for a loop is like, for modern diffusion models at least, I tell them the noise. That's a condition. Like I tell them the time step that I use for like that we're at in the noise sampling process, and then obviously my Gaussian noise is always generated basically the same kind of parameters. So I'm a little confused at how this becomes a problem. But maybe we're talking about older models where they're not given the time step as any kind of condition or embedding. And so maybe that's where this comes into play. So they decide you should have the diffusion denoiser be an implicit classifier for the amount of noise. So they leverage the noise classifier interpretation to introduce a novel self-supervised loss function to regularize the training called contrastive diffusion loss, which provides training signal in regions that are out of distribution for the standard. Okay, so are there really regions that are out of distribution for standard MSC diffusion loss? What does that even mean? We show that CDL improves the trade-off between generation speed and sample quality. Sure, just that it's good, right? Okay, so equation 2 expresses the probability density of the data directly in terms of the denoising function. If we apply equation 2 to the noisy distributions that bridge the data in a Gaussian, we can see that all the mixture densities can be written in terms of the same optimal denoising function. I am not going to go through their entire derivation right now. But so expresses the probability density directly in terms of the denoising function. Oh, equation 2 is up here. I was like, what am I looking at? Okay, let's grab symbols real quick. What is C in this case? C. Anyone see C? I need it. Oh, constant. It's a constant. Okay. D over 2 log pi e minus d over 2 integral from 0 to infinity d alpha sigma alpha does not depend on data will play no role in our approach as it cancels out our derivations. Oh. Okay. Plays no role in their approach. Got it. Okay, so the log likelihood can be written exactly in terms of an expression that depends only on the MMSE solution to the Gaussian denoising problem. Yeah, so far I'm buying it. I'm not seeing the part where the model is a noise classifier yet, but maybe I will see it soon. Intuitively, if we find that the optimal denoising function for the data distribution may be hypothesized that can denoise an already noisy version of the data distribution. Do I buy that? Do I buy that? Not if I think that that changes the distribution fundamentally, which aren't they kind of saying it does? Differences in log likelihoods lead to cancellation of constants, and these log likelihood ratios are related to the optimal classifiers we show below. To connect LLRs to classification, consider the following general model. We generate a random binary label, okay. Then, condition on Y, which is my random label, we sample from some distribution. Given samples, the Bayes optimal classifier is in the second line because probably is 1 over 2. Yeah, because the probability we defined it as 1/2, right? It's a random binary label. The constants cancel out. Then we could just expand definitions and rearrange to write in terms of log probabilities. Okay. So right here, they're telling me because this is always 1/2, it cancels out, which is how we got to this. Okay. Probability of y equals -1 over, well, no, the q of x for the negative y is the q of x for the positive y's. Okay, I'm still missing the part where that convinces me that the unconditional diffusion model is classifying the noise. I'll come back to that in a second. What is the actual loss that they define? So the new connection between diffusion denoisers and noise classifiers to train a new training objective. They define two distributions to be two distributions at different noise levels. So I suppose we're writing all this math in terms of like this binary classification, but obviously we have to generalize it in reality to more than just two noise levels. We can write in terms of the optimal diffusion denoiser from equation 3. Write it in terms of this guy. Okay, so we have this loss, which is essentially this, right? Yeah, soft plus of log of x minus log of x. Which is basically saying like, this loss is basically exactly what they said it is, right? It's like a prediction of the noise level. We got to estimate both densities directly from our denoising model using equation 3 with the constants canceling out in the process. This loss differs significantly from the standard diffusion loss and to distinguish between a sample from the data distribution versus a noisy version of the data distribution. We need to evaluate the denoisers on points from both distributions. Yes, that's what this does. In standard diffusion training, denoisers at noise level, whatever, are trained only on samples from. So this looks like we're saying that we want to just minimize the gap in our predictions on samples from the two different data distributions. It's like we'll have the data distribution, we'll have the noisy version of the data distribution. When we're actually training the model, we would sample a point from each and make sure that the like representations we get for them are really close. We highlight that CDL is more expensive to compute than standard diffusion loss, significantly increasing the total cost of diffusion model training. Okay. Choice of noise to contrast next. Let's break out the log likelihood ratio. Okay, I don't think I want to read that. I think, okay, so the things that I'm, like, the nits I have to pick with this are, so they're borrowing the title structure from a popular paper that said your diffusion model is secretly a zero-shot classifier. And the thing that I think I don't like about this is I don't think that your diffusion model is secretly anything if they're not showing me how the like other existing pre-trained models can give you some real estimation of the noise, right? It's like they chose this catchy title to justify some of the derivations that they do to motivate this contrastive loss, which is basically like a way of trying to say, I think that some of my sampling is going to handle out of distribution points, and so I'll just try to have my model handle those out of distribution points as if they were in distribution. I am not seeing actual noise classification anywhere in the paper, which I was kind of hoping to see. Um, yeah. I don't know. I think I've seen enough for now. It's it's an interesting thought, but part of why it didn't catch on probably is first off, people are probably bothered by the detachment between what the claims seem to be and what the paper is, and then also if it's just more expensive to train, right? And I wonder if, they'd probably didn't have a lot of resources, so they could only go up to 64 by 64. But even then, like you'll see, like the differences are big on the most toyish data set, and the differences are already totally vanishing. And this is just FID, which is like super noisy metric. They're already vanishing just as we get up to 64 by 64. And like at the point that we're at now, those of us that do like text to image, we even look at like the ImageNet stuff and the FIDs as basically like a toy problem and potentially total noise compared to what actually works. Like there's so much you can do to hack and optimize the FID on CIFAR and even still on ImageNet that it's like, does that actually work for real models trained at scale? Who knows? And in this case, given the extra training cost especially, I'm going to say no. But an interesting little idea. And I'm always happy to go over viewer papers. Okay, and like I said, gonna end the stream now. Gonna answer all the questions that are on the screen right now, and then I am done. So, do you think the current embedding based? Okay, I started to answer that. I think you clarify that. I'll answer that in a second. I mean, do you think we currently represent information the way we currently represent information is a bottleneck for the next big breakthrough? That's very complicated. I think it's a barrier to some, or it's more like I don't know. We is very broad, right? Because some people are, like LLMs are just using text tokens. Some people are trying to use pixels for things. Some people are trying to use points. Some people are trying to use depth maps. Some people are like there's so many different signals. Do I think we have to fundamentally change the way we sample signals from the real world to get a breakthrough? No. And do I think that the way that we process the signals shouldn't be some kind of embedding? No. But like the current embeddings and the way we do that sort of bothers me. The uniformity bothers me. We force text tokens and image tokens into the same space and audio tokens, right? There's something pretty clearly unsatisfying about processing an image as tokens. We define these very unnatural boundaries. We basically just chop up the image and we say these are the pieces, these are the tokens, and we say this much of an image is worth as much as this one word, or like we force the model to grapple with that. That's pretty obviously unsatisfying, right? And then we take audio, we force audio into that paradigm. Audio is this continuous signal. At least the images, we had a natural way to make it discrete. Well, the audio is continuous. We have to make it discrete, I guess, to store it on the computer, but then we have to discretize it again to feed it to the model and define token boundaries there and then line it all up. And I don't know, it starts to feel very much like we do the thing that works right now, but it feels unsatisfying. I would say the even bigger bottlenecks still, though, are just compute, right? The neural networks still have way less connections than the brain does, and so less neurons than the brain. And also, because it's easy to compute connections that we can model as matrix multiplications, there's not necessarily the same kind of spikiness or like that kind of behavior. There's also not this idea that we can like smoothly evolve because we need to parallelize the compute on like real GPU that really want things to be lined up nicely. So all those things are kind of their own bottlenecks, right? And then there's also just the elephant in the room of like the mechanisms by which our brain operates evolved over the course of billions of years, right? And we're kind of like playing God trying to like discover it from the other end, where it's like we still don't really know exactly how the brain works, but like let's try to just build one ourselves anyway, right? That's kind of hard, especially because we're actually operating in a relatively compute impoverished regime. Like we know we have less connections and we want to beat it anyway. And we know that we're really far away from being able to have a computer that can support the number of connections. And so, I don't know, I think it's pretty hard. But the mechanisms we have, obviously, especially in vision, exhibit bad behaviors. Like, I don't know if you've noticed, but vision encoders lately are just getting smaller. Like, not only can we not, like, figure out how to scale them. If anything, we're moving backwards, and like we just can't figure out how to get juice out of more than like I think the number that like Chanwen has settled on and like Gemma are like 550 million parameters. That's tiny. Uh, LLMs, I think some people are getting towards like 1T, right? Or even above. I say towards. Like we're on like that 1T scale, maybe. Um, Especially for like some of the largest models, but what are the returns once you go larger than that? And the fact that there are diminishing returns is unsatisfying. I think also the issues of like memory and continual learning are tricky. I think a lot of what we're figuring out lately with skills files for agents is like a way to kind of mimic that continual learning or memory. Like every time your agent messes something up, it can make a note about it and then load that in the context later, and then it kind of knows. But that's really expensive, right? And like we're spending tokens every time to like remember things, but remembering it really means reading it again from scratch verbatim. That's not very efficient. So yeah, I think how we represent the information is definitely a key bottleneck. It's not like the way we do it right now is terrible. Obviously, it's pretty great, but like it's probably not the perfect way. What do you think about Jürgen Schmidhuber? He is the real inventor of everything, even Transformer. No one gives him credit, not even Turing Award, or the rest we admire our copycat, including Jan. I think that I don't know. I'll illustrate something quickly. I talked about it on the last stream. If we look at that Schmidhuber blog, what's the famous one where he like lays out? Is it this one? We were in this the other day. Like, okay, so one example of like some of my issues with this. I hope this has the paper. Uh, does this have that paper? We looked at it last time. I can't remember the name to save my life. Some of his complaints will have this flavor, and I'm trying to find the exact paper, although maybe he wasn't even aware that he had this complaint at the time. It's his complaint that like LeCun was not the first one to use backprop in CNNs. Okay. Um, let's see. Is it this one? Yeah, it's this one, I think. Okay, so I want to point something out, okay? So this is the paper that supposedly did CNN with backprop before LeCun, right? Okay, so Schmidhuber has done us a favor, I think, and has given us an English translation, but this is the thing that we are complaining did backprop with CNN before LeCun. And I don't know if I can get it here. I mean, just take Schmidhuber's word for it, basically. So it was a, I believe, Japanese language paper published in a Japanese Society of Applied Physics journal. So like a niche physics venue. Okay, and we're complaining that let's see. The other Schmidhuber blog post makes it way more clear. But I believe the paper of LeCun's that we're complaining was after that is this backpropagation applied to handwritten zip codes. So we have paper that appeared in the Japanese journal in 1988, and we have the paper that appeared in, I want to say it was at like actually at NeurIPS, right? Am I crazy? Like I want to say this was NeurIPS 1989. So it's like I highly doubt LeCun or maybe anybody that even knew that this other paper existed. And also since I can't read Japanese or find a real version of the paper, I can't really comment on that. But I guess a lot of the complaints seem to mostly be issues of concurrency where like, yeah, concurrent work exists and you try to be aware of it, but especially when it comes to like back then, it's like to know that that was happening in that journal, you would need to like have ordered that journal, the paper copy. And I would highly doubt Bell Labs ordered the Conference of Japan Applied Physics to be delivered to them, or wherever he was in 1989. So I don't think he knew about that one. I think that's probably true of a lot of these complaints. The other flavor of these complaints is it's kind of like the reviewer that constantly comes into your work and says that it's, oh, this is just like this, but it's not a thing that is just like. Um, it's a thing that has some similarities, but a lot of differences. Schmidhuber's done a lot of great work too, though, obviously. Like I'm not like firmly taking a side, but I will say in doing a lot of this complaining, he has sort of debased himself as sort of like a meme within the community, right? Where it's like people can say to each other like, oh yeah, like Schmidhuber invented that about any random thing, and like everybody knows what you're talking about, right? I mean, and stuff like this really does not make him seem less meme-like, right? Like anyway, that's my brief commentary on Schmidhuber. Will I be ready to research after finishing Andre K. Neural Network Zero to Hero? Micrograd, language modeling, activations and grains, batch norm, backprop, wavenet. Let's build GPT from scratch, GPT tokenizer. It's a great start, yeah. Will I be ready for research? Depends. Some people might be, other people definitely wouldn't. You'll definitely be a lot readier to understand research, and it'll make a lot more sense to you, and you'll even, some of this will let you understand problems at a level of detail that you really wouldn't have otherwise, right? Where you get past the ideas that are just being presented typically in the paper, and even get into some of the nuts and bolts that really are like making things work. So it would certainly make you ready to collaborate on research. I don't know, like a lot of doing research is having your own ideas. A lot of that comes down to like taste and experience, and that's a lot harder than just learning technical content. But yeah, going through this course would probably make you ready to be a decent contributor in some language group. Where do we need more research, pre-training, or fine-tuning? Do you think we can do better than transformers? Personally, I think if you have the right pre-training objective, everything should be pre-training. Well, or there's no such thing as pre-training fine-tuning. There's simply training. There's designing the network and there's training. That would be satisfying to me. I think the distinction between pre-training and fine-tuning is pretty unsatisfying. It's pretty obvious why it works. But yeah, not clear. I don't think that's the best way to do it. And transformers also, like very, very strong network, sort of the nice universal architecture, just learn a lot of patterns from data, but probably not the optimal thing, right? I don't think, like dense attention, I think is clearly suboptimal. I don't think we need to compute, like, you don't need to compare everything in a sequence to every other thing in a sequence. And we already know that, right? We already have many sparse attention mechanisms that save us a lot of time and that still get great results. So we know some of these things. So we're making adjustments, but I think all these adjustments point towards the underlying inadequacy of the structure itself. But they're really good for now. How are you? Panic Compiler is here, Matt. Hi, I'm actually just going offline now, Panic Compiler. I said I was answering last questions. I'm just going to make sure I've gathered all of them real quick and I didn't miss anyone after I came back from my break. I did say, I said I would give a take on world models, I think. Did I already give that take? I do think they're learning some physics. I think like you can look at the recent like VBVR WAN. I think they're learning some decent like planning, which I think is cool. And I think you should be able to learn physics from pixels ultimately, or like a representation very similar to pixels, because the humans can learn intuitively physics just from pixels, right? But combined with the priors that exist in our brain. But so you give it the right priors, and then you ingest pixels, you should be able to learn physics. So I think I don't see why we wouldn't be able to have a model learn physics. And so yeah, world modeling, we're typically talking about like a model that can do the planning and the reaction and the action for like robot, for self-driving car. Sometimes we're talking about like video game model that responds to like user inputs. Predicting what happens if I do a thing, right? And I think we should be able to learn that from pixels personally. I am also live and you are in my stream on YouTube. Oh wow, cool. Anyway, okay, so yeah, I think I answered your question, Mohammed, right? yeah, I think you'd be ready to participate in research if you actually understand all the concepts in that course, at least on the linguistic side, right? It doesn't really touch the vision side as much, but some of those things transfer, like backprop, for example. But anyway, that's all for me now. Thank you everyone for tuning in. It was a fun stream. I always enjoy reading the papers and answering the questions, and I'm looking forward to seeing you all next week, 9 a.m. Pacific, or translate that to your time zone accordingly. Take care. Bye for now.